and
interruption.
it.
Are you listening me, sir?
Let's go ahead.
Sir, your
Yes, yes, you go.
not shared.
My voice is not audible.
The screen has not shared for the PPT.
What happened? Sorry.
PPT you have shared is not visible, sir.
Oh, is it okay? I just shared my entire screen. It says I shared it. Just a second. I will share the entire screen. Entire screen. Is that? Can you see this? Or no?
Now it is available, sir. You can continue.
Okay. All right. Okay. All right. So basically, the title of the talk is Adaptive Controller with Integrated Threat Avoidance for Swarms. And as I was mentioning that UAE is used in surveillance, mapping, inspection, search and rescue operations. And in Swarm, there is no centralized coordination; it's all decentralized. And basically, they operate under uncertainty, and there are dynamic threats like missile attack and things like that. And UAE swarms follow the same principle based on the local interaction and that is observed in natural flocks. Basically, what is a swarm? As I mentioned, swarm is a collection of interacting agents, and basically the agents belong to a group, but are not necessarily identical. So there can be different type of agents, and they contribute and benefit from the group, and they can recognize, communicate, and interact with each other. And a swarm is better understood as agents exhibiting a collective behavior, and there's no centralized control or leader, and collective behavior emerges from local interactions. So when I say swarm, it is basically you have observed in nature. I have a picture over here. So this is an example of a swarm where there's a group of birds flying together. So here, in this case, when you see this kind of swarms, they don't have a centralized controller. So they all interact with their neighbors based on the local communication. So each of the agent or the birds in this case will communicate with the local birds, I mean, with local neighbors or neighbors around them, and communicate and coordinate, and such that they all fly together. So it looks cool. And when you, this was why we need to model swarms is basically it looks very cool and the motion looks continuous, but agents are discrete. And there is local perception of the world because each agent has their own sense of their world. And the main since I'm from computer graphics background, when you want to animate these swarms, traditional animation technique like keyframing technique is hard, and it's also hard to script the path of the swarm, uh, and the behavior is emergent. That's very important. When you have something that's emergent, it is very difficult to have some kind of an uh, some kind of a scripted path, because you need to edit the path if you want to change. So and it's very difficult, to edit the motion of the swarms. All right. So this was the swarm algorithm was introduced by one of the famous computer scientist. His name is Craig Reynolds. So he has contributed to the area of swarm, and back in 1987, based on that, many research work has been done. And swarm in that time it was not called as like swarm intelligence. He named it as Boyd's model. And Boyd's model is basically um, a Boyd's model is nothing but it's a contraction. What do you mean by Boyd? It's basically a contraction of bird or like object. It was coined by basically the person who invented this, Craig Reynolds. And these are nothing but autonomous agents with position velocity. They only react to nearby neighbors. And this is the foundation of rule-based locking. And there are simple local rules which can create a complex global motion. And it is very mainly used in computer graphics, robotics, and AI recently. And Boyd means like you can imagine Boyd as an agent, or Boyd as a individual agent, or in group of birds or flock it's like a bird, and in a school of fish is the fish, and in herding you that's animals, it can represent anything. So that's why he has coined the word boid. It's a uh, bird-oid object. All right. So when I say boid, please assume that's an agent basically. So because I want to go by the original definition by the author. So basically here, the boid has a geometric shape and orientation, and boid has a local coordinate system, and behavior depends upon the neighbor states. And I mentioned this uh, picture, so group of birds flying together. And basically, there are three classical Boyd rules, which is coined by again Craig Reynolds in his seminal work. And one is called a separation. Separation is basically to avoid collision within the agents. Alignment is basically to match the uh, velocity with the neighboring agent, because if a bird in a group, because they have the same kind of similar kind of velocity, and they don't like go too fast or too slow when compared to the neighbors. So basically that is called as alignment. And then cohesion is like you still have the separation, which will separate each of these agent from each other, but they are not separating and going forever. There's some kind of force that is needed to move those birds, coming to a common basically cohesion, as it says. They fly cohesively, or they fly together, so they steer towards the centroid of the motion basically. And as I said, each byte here interacts only with the neighbors, and neighbors are defined by visibility radius. And if the visibility radius is by a circle, here in this example, as you see that there's a byte, it represents a triangle over here, and you draw a circle around them. So these are the visible neighbors, which is like mentioned here. So this is called as a perception radius. And the outside neighbors are not visible, because it's like a field of view basically. And here's omnidirectional sensing, because it can look in 360 degrees. Basically this neighbor set is basically used to compute the separation, alignment, and cohesion forces. All right. So separation is basically a repulsive force from neighbor agents. It dominates at very short distances, because it acts more, if they are trying to come too close, the agents try to come too close, then the repulsive force acts at a um, larger, larger repulsive force acts, and then, then it is going to prevent collision. And this is calculated with the following formula. Basically, it's nothing but a difference between the position of a void, current void, and the neighbor voids, and that is summed over. So that is, so you can see that, whoever is in the visibility set or in the perception radius, and those is accounted. And this is the separation vector basically. This is nothing but, difference between 2 points. Basically, there's nothing but vector. Here, points, I mean the position of the current void and the neighbor voids. So we're going to sum that, and we're going to find the separation vector. And then we have cohesion. Cohesion is basically uh, it's an attractive force which is going to attract towards the local center. So we need to find the centroid or center. So the center is calculated using the formulas. This is again calculating from the visibility set, and basically m is the number of bytes. So in the visibility set, so you're calculating the average center. So that's an average. You're taking average of position of all the bytes with respect to the current byte. And then the displacement vector is calculated by subtracting the position of the current point from the position of the center of the flock. So this is given by here. So this is the cohesion vector. It's given as like k. And previously we calculated the separation vector using that formula and the cohesion vector. And finally, a velocity matching is basically it's going to be calculated using the formula given over here. So basically, v stands for the velocity over here, and it's going to compute the velocity of the neighboring bytes, and it's going to produce the coherent motion. It's going to stabilize the heading, because all the bytes will basically are going to point in the same direction as given here. So if there is slightly offset in the blue color, you can see that the byte. So this direction is a little bit off compared to the rest of the bytes. So it's going to align that, because all the birds in a flock are going to head in the same direction, right? It's called as alignment or velocity matching. And when you combine all the steering vectors, basically you are going to combine in one these three vectors. We have computer separation, alignment, and cohesion, and that's going to give the direction of wide movement. Basically, you are adding all these vectors together. So as a vector sum, and then sum them to calculate the final direction of that movement. It's called as the final steer. And the assumption in classical Boyd is that it assumes omnidirectional sensing and fixed rules weights. Basically, you are combining all these vectors and you're assigning weights to each vector. Basically, whether you want a separation to dominate, cohesion to dominate, or um, alignment to dominate. So basically, fixed rules is one of the main thing, and you have to choose these weights properly. Otherwise, you will not get the motion that you expect, and there is no explicit obstacle or goals, in the assumption of classical voids. And but in the real UAV constraints, which is like unmanned aerial vehicles, this we have something called forward facing limited field of view. We have this sensors, and which can detect only not in the all direction, only the forward facing direction. And there is also like when you talk about um, swarms, which is used in attack, military attack. There is also dynamic, fast moving threats, and they also need to reach a target. And there's also, when there is no neighbors around them, there is a risk of stalling under this parts visibility. So these are some of the constraints that you see in the real when you apply this swarm algorithm by Craig Reynolds for UAV application. And basically, what I mentioned is that this is the field of view, as you can see from this diagram. Um, um, Basically, you can see that the drone or uh, current drone, it can see only the whatever is with respect to the visibility radius. Basically, does not have omnidirectional sensing because of the forward facing camera or sensor. So only these two things are visible, and these are culled. Basically, they are not visible, right? So this is called as a field of view, which is FOE. So this FOE angles limits interaction, basically. So this is a velocity control field of view based on the current heading. We are detecting like who is in the front and who is not, basically, within that theta. And the why I say is an adaptive controller in my simulation, in my presentation, is that unlike the Craig and Reynolds original work, he used fixed weights, and the weights are does not adapt to the situation or the current situation, current environment. So I have the formula in my paper where we calculated that, so we that how we calculate these weights dynamically. And so that's the main contribution. So we calculate the weight dynamically, and each of the drone or UAV adapts its behavior based on these adaptive weights, and also uses local sensing. It neighbors, and it has obstacle, it has goals. So those are the things. And it's a control loop is like this. So per UAV control loop senses local neighbors, obstacles basically comes in like in terms of like missile attack, attacking the drone. And there's like goal also it senses. And as I mentioned, sensing is limited by the velocity line field of view, and compute the steering forces, adapt the rules, weights, basically it's separation, cohesion, alignment, which I described earlier. And based on that, it's going to, based on the local condition, it is going to adapt these weights for those rules, and then combine similar to the voids, and it's going to update the velocity and position of each of the drone. So the inputs are going to be again like local, so neighbor position and velocity within FOV, and distance to the obstacles and threats, and distance and direction to the goal, and number of visible neighbors. And the final output is the final steering velocity for the drone or UAV. and there's no global communication and swarm level computation, right? So here we don't have a centralized controller. That's what I want to say. So in original Boyd algorithm, we had three rules. Here we have five rules, and there the weights are fixed. And here we have adaptive weights. This is just a comparison. And there we have omnidirectional sensing. Here we have like a velocity aligned field of view. And there was no explicit goals or threats. We have explicit goal and threat handling and five steering behaviors. So this is separation, alignment, cohesion are coming from the previous work by Reynolds. Now we have obstacle avoidance, and migration term is basically moving the drone towards the target. And basically, the important thing you want to note that is the two more behaviors are there, which is obstacle avoidance and migration. And fixed weight controller is constant roll weights, and here the weights in my proposed work, the weight change every time step based on the local conditions. And this is um, offline computer. This is computer online, and this is sensitive density. Here's just robust to density variation, and basically the fixed weight fails under narrow field of view, but here it operates under sparse visibility as well. And the adaptive controller is smooth, and the weights are smooth, so it has more continuous. There's no abrupt switching between the behaviors. Like behavior, I mean that the rules, the five rules I mentioned, and there's no learning, there's no memory or no delayed feedback. It's like instantaneous. And this control is not learning based, not optimization based, or centralized controller, or not depend upon the global communication, right? The migration term is going to move the drone towards a global goal, and not necessarily required for the birds. It's essential for mission-oriented drones. And when I say ungated, basically it means that there is a constant pull towards the target. So here you are not using the field of view for the migration term. That is the to guarantee the forward progress, and it prevents from stalling. Stalling is that when there are no neighbors in the case of sparse visibility. So there is a migration as it acts as like a persistent bias, so that so that the system does not collapse to zero velocity. And obstacle threat avoidance in case of birds, you can think of a predator like eagle chasing like other birds, so that it's like they avoid naturally in birds. And here UAV have like mission like dynamic threats because the threats are dynamic, and it requires explicit avoidance computation, and we use the closest surface point to detect the threat and avoid the threat immediately. And we also use the produce escape direction, lateral escape direction. It reacts faster to the obstacles when I use closest point, surface point for detecting threats. So I think I mentioned this basically before. And let me just go to the simulation setup. So we did the simulation in 2D, and in the XZ plane. You know, we didn't go for 3D. We are trying to implement in 3D, and we have the custom built framework in Unity, and time obstacle basically fired from the ground at interval of 1 to 5 seconds interval, and it's directed towards the centroid of the swarm. And basically, we try to change the field of view from 60, 120 to 180 to 14, etc., and try to get the map random seed ran give random seeds to evaluate the algorithms. The metrics evaluated are collision count and compactness, pairwise distribution, and density variation, and average flight time to the target. And the key results is that I just want to mention the key result is that I know I'm running out of time, and the key result is basically um, we find that with the adaptive weights we had a 40 to 70% of crashes, less crashes. That is the drone not reaching the target because they are attacked by the missile which is launched from the ground. And even in case of narrow FOV, the adaptive controller performs much better. That means that in case of even that, you can translate that in there's no neighboring void. or neighboring drone. In case of sparse visibility, also it just performs much better compared to fixed weight controller. And these are the key result. And we have this, average density between the adaptive and fixed weight, and the flock compactness, how they are close to each other. They are not like spread out. So you want that drones to fly together. The compactness of the flock, we just calculated that as well. And the average pairwise distance also has been computed between uh, 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 between these two controllers, fixed weight controllers and adaptive controllers. And the mean flight time to reach the target is also computed, that you can see that key results. And let me just go and show the simulation. Um, just a second. I think it is not 1 minute. I just want to show the simulation. So in the case of fixed uh, weight controller, you can see that, this red color here. I just want to. Are you able to see my slide? Are you able to see this video?
Um,
No?
yes, sir.
Okay. So here we can see that, that this green color is the target. So these are the arrows here, means they are the drones. And basically here the field of view is 360 because there's omnidirectional, so it can sense in all direction. And we computed all these metrics that you can see over on the left. I think this is the fixed weight controller that I'm showing you right now. And I think let me make sure that I'm selecting a fixed weight controller. And you can see on the bottom, you can see that, how many bots have crashed or how many drones have crashed. And you see that red colored dot appearing towards the centroid of the swarm. That is nothing but the missile attack that's launched from the ground. So when you see that, you can see that I just paused the simulation. So when there is, this is the missile attack launched from the ground, and it is in the XZ plane that's happening. And you can see that when the missile attack is there, it tries to avoid this one, and try to reach the target. In case of fixed weight controller, you can see that the number of bytes crashed or number of drones or UAV crash is 28, as you can see here. And whereas in the adaptive weight controller, where the weights adapt based on the local conditions, uh, let me just show the adaptive weight. Um, you can see the adaptive weight controller. Here you can see that, it tries to, avoid that. And you can see the number of drones that have crashed is basically, uh, that previous case was like 28. In this case, it was basically, you can see from the bottom here, the number of crashed uh, drones or bytes. Basically, in case of adaptive control, is just 10, using the same seed and some. And this concludes my talk, and I will answer any questions that audience might have. And thank you again. Uh, I'll wait for your questions. Thank you.
Hello, sir. Am I audible?
Yes, yes.
Sir, I have a question.
Mhm.
How is swarm intelligence different from traditional AI decision making?
In AI, I mean, Swarm is actually is a subfield of artificial intelligence. It's a subdomain of artificial intelligence, basically. In AI decision making, you have something or like the same Swarm drones that you see, for the drone show. They have the centralized controller, so something is controlled. But the Swarm is not. This main important thing is decentralized. That's a main difference, and it's a subdomain of artificial intelligence, I would say. And it's not the same, but it's a subdomain.
Okay. Sir, I have another question.
Mhm,
If we had to redesign the system 5 years from now with emerging
mhm,
technology in mind, what would you
mhm.
change first and why?
See, first this one is basically it's instantaneous because we need to work with the real one because First, we need to develop this algorithm and work with the real drones. And here, everything is simulated. And in real, there's like problem with the sensors, how the drones communicate with the neighbors. There's also delay in, in communication. There's definitely a delay in communication. So how we are going to handle that, and that will be very important stuff. And and other thing is that when there is like a threat like that, there should be a broadcast. There's something that right now there is nothing like that. The swamps, they don't communicate to others like about the threat, so that should be a threat detection being done. Of course, moving to 3D is very important. So moving to 3D and working with, collaborating with someone who is working on um, real, I'm doing the simulation. So I just want to collaborate with people who are working on a drone simulation, and asking them to code the algorithm. And when you see, this is research. When you implement it in reality, there will be a lot of problems, like as I said, that the sensors, communication delay, and everything. And so those things should be addressed. So those are the things that I'm interested. And also, you want to apply the um, here the weights are computed, so you want to also use uh, you know machine learning and incorporate that as well as a part of this model. So that one of the student was telling me that he wants to work on that here.
Thank you, sir. Thank you.
Any other questions you have?
No, sir.
All right.
Thank you very much, sir, for that enlightening and insightful keynote address. We truly appreciate
All
your
right.
time and expertise.
Yeah, thank you so much for introducing me. This is the third time I'm delivering the keynote address at Amit University. I'm glad that you've been inviting me again and again. I hope I would um, come in person, because my classes have started, so I couldn't come in person. But I hope I will at least join next year in person. Thank you very much.
A very good morning to all the distinguished dignitaries, respected professors, ladies and gentlemen. At the outset, I, Tejaswita Singh, express a warm, respectful welcome to the 16th International Conference, Confluence 2026. Recent trends in artificial intelligence and data sciences, innovation in cybersecurity, AI, and digital forensics, advancement in IoT, networking and cloud computing, organized by Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with strong foundation and a platform for the empirical inquisition. With this agenda, Confluence 2026 intends to bring together professionals, academics, industry experts, research enthusiasts to discuss various emerging trends and innovation, share research results and new directions in the field of the next generation technologies.
Moving ahead, it gives me immense pleasure to introduce our next keynote speaker. We are privileged to welcome Mr. Subhangarangam Malviya, Director of AI Innovations at LSEG and a senior member of IEEE, with over 22 years of industry experience and more than a decade of deep expertise in artificial intelligence, big data, and cloud platforms. Mr. Malviya has held senior leadership positions at globally renowned organizations, including JP Morgan Chase and Samsung. His expertise spans generative AI, large language model, GPT, GANs, deep learning, computer vision, recommender system, and end-to-end AI model lifecycle management. He has successfully led global teams delivering AI at scale platforms with billions of daily interaction and sub-second latency, generating significant business value. As strong advocate of industry academia collaboration, Mr. Malviya brings extensive expertise working with global organizations such as Netflix, Amazon, Walmart, Nokia, and is passionate about leveraging data driven innovation for social and enterprise impact. May I now invite Mr. Shubhangarangam Malviya to address the gathering.
Hey, hi, thank you. Hello, MIT, and hello, all the academicians, students, and all the dignitaries. Um, Today, I'm going to speak about a topic which is agentic frameworks with LLMs and SLMs for the enterprise products. Now, this is an area which is and has been of a lot of importance, and a lot of companies are giving a lot of attention to this. So, by the way, I can be contacted on my LinkedIn, and I also put a QR code where you can connect and we can talk about it. Any questions that I can't take online can be posted on LinkedIn and I can answer them. Today's talk will mainly be, I'll be focusing on um, how these models, like the large language models, are evolving into systems that are required for our industry. Because these systems that because right now, let's say using ChatGPT, you get some answers to the questions, you are able to translate something, but those are not the use cases that industry looks for. Industry looks for much more complex use cases, and that's what I'm going to talk about here. um, I made this presentation pretty light because I wanted to introduce you to agents. I'm not sure in your journey, in your learning journey, where you are. And I'm going to give you a practical approach to it. I'm not an academician. I'll not talk about numericals, formulas, and so on. I'll be talking about what practically we are doing in this industry. I will give you a glimpse of how evolution is happening in the agentic frameworks. Now, how these large language models, small language models are evolving, and also talk about um, a, a very generic design of how systems are being developed using the generative AI models. Um, Eventually, I mean, in the end, I talk about the future of the agentic frameworks also, wherein what that maturity model looks like 2 or 3 years from now, and where we are in the industry. And thanks a lot for my introduction. Practically, I run um, COEs, which is Center of Excellence on Generative AI in my company and in the past as well. So daily, my projects, my work is revolving around agentic frameworks and large language models. I have been an early adopter of the large language models in the past as well. To start with, I talk about the agentic AI. So when we started working on transformers, so there were some very initial transformers like BERT, and which were like more like encoder decoder models. Then after came the large language model, which transformed the way the world looked at the things. Because one, in your hands or in hands of the non-technical people, the business people, they got to know that the power of the AI for the first time. Now, those language models have evolved into a more encapsulated systems, which can be defined as the agentic AI, where agentic AI does multiple jobs. One, and if I go by the definition, it's capable of operating autonomously, making decisions, adapting to complex environments with minimal human oversight. We are not there yet in terms of saying autonomous, but decision makings have started happening. And if I talk about the three key goals of an agentic AI framework or a system, then autonomy is the most important, wherein in the runtime, uh, a system is able to decide which workflow to be adopted. Uh, Goal oriented, there has to be objective attached to each work. You can think about use cases. For example, let's say you want to plan your travel um, from let's say Delhi to Chennai, and then the agent should be able to give you the best price, give you the best model, and maybe if you want to say, hey, I want to travel based on, I want to do a travel wherein I spend the least, then able to prioritize based on the demands of the user, and then the learning capabilities around it. So how from the actions the models can also learn. Now, where we are in the journey right now. This is a slide that uh, the this is something that has been talked by OpenAI, and the way they factor that where we are, the stages that they factor in, where and how we are going towards AGI, which is artificial general intelligence. So initially, the stage that we were in the past, which is till 2023, or beginning of 2024, we were more like in the phase where there were chatbots. The chatbots um, were showing the capabilities, let's say customer service bots, model bots, and so on, and we're able to answer the questions, follow the instructions, and able to perform the tasks. I'll not say that that particular phase has matured, but now it's more like an engineering problem, a solved problem where people are able to make bots, companies are able to make applications around it, and then make sure that they evolve to the next level, which is the reasoning AI, wherein you have the large language models doing human-like reasoning. Now, this is a phase where I will argue that we are still there. We haven't completely matured ourselves because there are aspects of hallucinations that are there. Um, a lot of times, well, I'll not try to put a number to it, but there are times that you may get a, a, a very human-like reasoning, but that might be hallucinating. So there are situations that LLMs will hallucinate. Their reasoning models are getting much better, are evolving much better, but still we are there we are there still maturing in terms of the reasoning AI. And then comes the next stage, which is the agentic AI, wherein we we want to have autonomous actions that can be easily done without human intervention or with very less human intervention. Now imagine the steps. For example, I was logging into Zoom and I wanted to be a presenter. So there's an admin who's making me a presenter, and there is no way that this can be all put into one workflow right now. So that's the current condition. But imagine there would be a time when agentic AI and innovation AI is going to go to an extent that because I am invited as a keynote speaker, automatically Zoom and Outlook are going to collaborate with each other or connect with each other. The agents are going to connect with each other. And then automatically I'll become a presenter when my time slot comes in. So those kind of scenarios are what people are developing, engineers are working on, researchers are working on some of the research aspects of it, and that's how the industry is evolving. Then comes the interesting part, which hasn't yet started. But think about the fact there are some of the use cases we would have heard about. For example, you would have heard about something like Google Brain, which evolved into coming with lots of new chemical new compounds, new that didn't existed, new elements that didn't existed, or maybe the drug discovery, which took much longer, got innovated through um, through the through the power of the AI. Now we are not there yet. There are some examples, Google Brain being the strongest, but we are not there yet. Imagine in a setup, for example, in a setup like maybe a college setup, a university setup, wherein innovation starts happening, the creativity starts happening using AI. So we are not there yet. We are just trying to delve between chatbots, trying to find faster support through agents and so on. And eventually, this is where we are going to lead to artificial general intelligence, wherein the final stage will be that AI systems are capable of performing the work of the entire organization, managing and executing a wide range of tasks without the need for an oversight. Now, you may argue that this is a difficult situation. What we are going to do, what I'm going to do if an organization is completely AI driven, that's a different topic for a different conversation. But that's how the artificial general intelligence is going to evolve. And the topic of the interest today is agentic AI, which I'm going to talk about. further. Now, before I go ahead and talk about agentic I want to talk about something about the small language models. Normally, people hear and learn about large language models a lot, but people may not know about it. And therefore, I wanted to spend one or two slides talking about small language models, giving you a perspective of why always one LLM doesn't fit for all the needs. These small language models are more like knowledge distillation models, where pruning or quantization has happened, and then we reduce to somewhere around 3 billion models or less. So this is a loose classification of a small language model. Well, I have written till 10 billion parameters, but normally till 3 billion parameters are what small language models are meant to. Now, the beauty of these small language models are you can port these to on-device AI. You don't need to be connected to internet, and those models are capable of performing specific functions. So and faster in inference speeds. So imagine you getting a response from an LLM in less than 50 milliseconds. So using small language models, so that is much more possible. And then doing some very specific tasks, like maybe only one LLM performing one specific task of natural language generation or summarization or translation, question answering, and so on. But there are some issues. It doesn't solve the problem of reasoning. So if you have to go with problems like reasoning, decision making, you have to rely on the reasoning models, which are the large language models. A bit of a comparison of SLMs and LLMs here. As I mentioned, the number of parameters change, training data is different, customizations are different, cost of using and training SLM is much less than an LLM. And we don't normally train an SLM. What we do is we take a LLM, we truncate it by the three techniques I talked about, and then we make a SLM, which is custom made and for our specific requirements. I haven't done any kind of SLM training, but that's how the companies like OpenAI, um, Anthropic, and others they make those models. Some examples I talked about, like chatbots, plain text generation, natural language generation. So these are some of the specific tasks that can be carried by SLMs. And with the LLMs, um, they are going to be more complex, like creative writing, like open-ended dialogues, and let's say a general conversation. If I have to talk to an LLM, supposedly that LLM is a multimodal one, then I can talk to an LLM and I can ask any question and can get a reply back around it. Now, those kind of complex tasks, because they don't have a domain on which we'll get an answers, are very important. And that's why LLMs become important, and they are the right fit for those kind of tasks, the general tasks. I spent a few slides and a few minutes talking about an agent. So what an agent is, it's a basic definition and basic role of an agent. I talk about here, um, I'm assuming that many of you know this, but just for the sake of entirety, I'm just going through it. So the most important part of an agent is a core. So this core is something can be called as the heart or the brain of the, I'll not say the heart, but the brain of an agent. And this is where normally the LLM sits. Now it defines the objectives, the core behavioral characteristics, what that agent is supposed to do. Then the attachments, which tools are attached to it. Then also strategize, like in terms of which workflows can be dynamically adopted, and then also memory and retrieval. So for example, do you want to put some context in the in a cache, or do you want to put that into a bigger into a larger database but retrieve it much later? So will you have a real-time retrieval, or you want to have a retrieval later on? So based on that, the dynamic memory selection and other, so all the decision making in general is done by the code. Then comes the planning agent. So the planning part of an agent, wherein the plans are decomposed. For example, let's say the example that I gave you, that if I have to plan my trip from Delhi to Chennai, making sure that I spend the least, then that task has to be decomposed into multiple tasks. That what does least task, what does least budget means, where you're going to reside, what kind of hotel, what kind of transportation is the most preferred one. So which is like giving a complex problem. The LLM tries um, to fork this into smaller questions and tasks, and then go ahead solving those problems. So it may talk to other agents and try to accumulate the information, orchestrate it, and then finally get a response back from it. Planning is just not about decomposition of questions and the tasks. It's also about even critical reasoning, even asking some wider questions, and asking maybe from the user also some questions. For example, maybe do you want to go to Chennai using through Mumbai or through Calcutta? Would you take a aerial route? Would you take a road route? Or are you adventurous enough to drive down? So those are some of the follow-up questions which are critical in understanding the user intent and then coming back. So that's a combination of a planning and a code that come into picture when an agent comes into picture for decision making. Tools are nothing but a set of third-party APIs which give capabilities to an agent. And um, imagine, let's say, for example, you want to connect some agent to a SMS servings, SMS notification service, or maybe connect to some kind of emailing service. So those tools are where all the API integrations take place. I didn't talk about the memory part of it. So memory is, there can be short-term memory, there can be long-term memory, and there can be some context that can be retrieved by the agents. So this is a basic unit of an agent where agent has memory, planning, tools, and code. And now let's see how this agent comes into play when we design a larger system in the enterprises. Now, this particular diagram is what I created using ChatGPT. And I just wanted to give you an interesting aspect. That's why I created using a ChatGPT. Just using prompts, I used a multimodal ChatGPT Probably 5.0 to make sure that I create this diagram. And this is not because of my lethargy, but I wanted to give you a perspective that the complex tasks of reasoning can be done by large language models. And this is where this is what I did. And this is a practical architecture, a generic one, which is used for agentic frameworks. I'll try to describe this here by starting with something like the user. So let's say there is a user tells, which gives some, which asks some complex system some query. Maybe let's say I imaginatively I'm using, let's say, make my trip to say, tell me a day when I can book a flight in less than $100 to let's say Singapore. Now, I didn't specify a day, I didn't specify an year, but I specified that, hey, my requirement is I want to book a flight within $100. Imagine this may seem to be more like a search problem, wherein the system goes and try to find out uh, when is the flight lower than $100. But to make it more complex, I say, hey, or on top of that, I can only pay $50 more for my accommodation, and I want to have 3 nights and 4 days of stay in Singapore. Now, think that this is a usual question a user can ask, but for a system, it triggers not just one particular database from where you can get this information, but you have to collate the data to make it more complex, uh, let's say there is also points that the user may have. So points are more like the credits that they have accumulated from their past bookings. There might be some discounts that might be running. Considering those functionalities and those criticalities, and the user simply says, whenever you get it, book it for me, just ask for my consent, and then um, show me the hotels. I'm going to choose one. I only want a hotel which is having a rating of 4.5 and above, and so on. So internally, what's going to happen? Internally, a set of this task is going to go through an orchestrator. The orchestrator uh, is again an agent. Maybe you can call it as an orchestrator or as an orchestration agent, which, based on the user query, the user intent, understands that which workflows have to be triggered. So, for example, in this case, the one workflow that I can talk about here is one is finding out if the user has some discount coupons attached to it, finding out when is the flight, when the person when the flight is less than $100. Excuse me. The other thing that the user has to also consider is the agents have to also consider, are there some running discounts? Is the user having some mileages, some air mileages there with the user? So considering all that and then coming up with that detail triggers a lots of agents in this place. Um, Travel agent is one, booking agent being another, then uh, maybe querying the credit card, saying that, hey, are there some credit card discounts? So in this scenario, you see the complex workflow orchestration by the task agent, then some of the reasoning being done by the complex reasoning by large language models, the agents which are sitting and encapsulating the LLMs, some of the SLMs as well. For example, SLMs might be required just to give a notification, may be required to block a particular ticket. And to standardize all this, MCP's protocols have come into picture. A2A, which is agent to agent connectivity, have come into picture. So this is a bit of an overview of how the standard agentic framework looks like. And with connectivity with lots of tools, databases, APIs, service, and then complex queries trigger complex actions, simple query trigger simple actions, and that's how the large language and the small language models comes into picture. Now, considering this kind of a scenario wherein there's not just one LLM call happening, there are multiple LLM calls happening, multiple LLMs are there in this particular scenario. How do you design the evaluation set for this? How do you how do you make judge that what the user wanted in this case, whether that user got it, and which particular uh, agent was performing better and which one was not performing better? It's a it's a complex question because maybe the discount agents didn't get the best discounts from the aggregators. The user may get some kind of itinerary within $150, including stay, but was that the best? So so maybe the user gets a response which is uh, which okay, the user may like or dislike, but did all the agents perform as expected? And that is where it all triggers to an area which is an active area of research as well. And I wanted to add this slide just to give you all a perspective of why these kind of systems are complex. Evaluation comes into picture. Now, whether a particular agent performed nicely, although the user was satisfied to an extent, but whether that was the best result by an LLM, whether that was deterministic result by an LLM, and that is where the LLM, and that is where the evaluation comes into picture. Classically, people say that evaluations are of two kinds: reference-based, wherein you have some golden data set. Golden data set is nothing but a curated set of the answers. And then you have reference-free evaluations, so which is you don't have an answer because it's a dynamic world. For example, in this case, $150 travel to Singapore, including accommodation. It's a dynamic use case. You can't have a data set which can actually tell you that what should have triggered in this condition. So it's more like a reference-free evaluation that has to be done. And reference-based evaluations are more like if you want to try out a particular agent, that may work out nicely. And this is where we are in terms of evaluations. I'll go deeper into this a bit, talking about some of the popular ones, and then I'll talk about the evolution, what I think is particularly going to happen in this space in few years from now. So reference-based evaluations are very standard evaluations. For example, I talk about the overlap-based matrix. It's more like you have a golden data set, you see the response from that golden data set, and sorry, the response from the agent and the response from the and you try to relate both of them using row, blur, and other scores. It's more like a F1 score. Loosely, I can say F1 score. Then the other things are like ranking matrix. So where you rank that if the response is the best response or what should have been the best response. And then the classical matrix that is always there, which is precision, recall, F1 scores, FN scores, and so on. So these areas are more where you already have a data set, you already have deterministic information, and you deterministically match the things. But as you move towards the right, you see I have changed the colors, and this means that we are moving into a more like free reference where you don't have uh, a, a golden data set, because the example that I cited you will have some examples, but you will be limited. You can't say that whether the LLM performed the best or whether a particular agent performed the best, and the performance of the entire workflow, whether that was correct or not. And that is where the free reference, and that's where the area of research is all about. You all should think about it. There are some frameworks available. I don't want to quote them because they keep on evolving, but that's an area that you should think about. Now, LLM as a judge was a paper that came in, I think, 2024 or 23. Uh, it's nothing but LLM judging a particular response. But now people have used LLMs as a judge or a panel for multiple purposes. So it's an evolution from the paper to a product is where we are right now. Then comes the standard matching techniques like statistical techniques, ML-based scoring, then semantic similarity, and then the most important, which is the users, like how the users rated it and how the competitor tools are rated with one another. Example, let's say how another travel agency gave a response back for $150 travel to Singapore versus our system. And that is what apple to apple comparison is all about in this case. And that's the most important. So practically in my cases where I work in, this becomes the most important because customer success is the goal for any systems that we build for the customers. So that is where we are, and evaluation becomes important. Lastly, I talk about something which I touched base initially when I was talking about evolution towards artificial general intelligence. And but I wanted to conclude this by saying that now we are in the world where agents, assistants is something what engineers are working on, what companies are working on. I'm in the Bay Area, and I know that a lot of people just talk about, hey, when is that time is going to come that agents will be available as if they are available as apps? So think about the fact that, for example, let's say you make an agent called a risk agent, which understands the risk profile of a customer, or a KYC agent, and then you sell that agent to others. So in your context, for example, banks like HDFC Bank, ICICI Bank, and other banks, they start buying the risk agent from the App Store, connecting it with their workflows and making sure that they are able to perform their task as and when required. So the job of integrating a particular API or connecting with others through after having a big contract or after having long discussions. So gone are those worlds. Those days are gone. So the world is evolving into something which is available, maybe through an agentic um, app store, sorry, agentic store, and then globally you can buy it. The companies can buy it. There'll be no system integrations in play because of the connectors like MCP and so on. You will have very standard connectors and you can dynamically connect to multiple agents. So maybe, for example, in the context of CADMix, let's say you want to basically um, hook to a lecture which was done um, only for select few, and you have to buy that and then propagate it in entire MAT. So you just need to go and buy it, and then after you buy it, it becomes more like a seamless workflow that comes into picture after some authentication or authorization coming to picture. So that's where agentic intranets are going to come and evolve. There are still early days, but I'm seeing companies trying to collaborate on building their own agents that they can expose to other companies. And then eventually, what's going to happen is Internet of Agents. So consider you will have every website may have agents. They say, hey, you just connect with our agent and do whatever you want to, not whatever you want to, but perform the functions that are available and connect with your interfaces. So, and those connections are going to be all no code and low code connections. So that is where this agentic AI is going to evolve, which is going to be Internet of the Agents. And that's how the Linux community thinks about. And this is where I got uh, this string called Internet of Agents. With this, I would like to end my keynote presentation. Hope the hope MIT and academicians attending this conference were able to enjoy and learn something from me. It's a practical engineering aspect that I'm telling in this keynote speech. Happy to take up any questions here.
Yes, sir. What are the key technical or ethical challenges in moving from agentic AI to innovation AI and organization AI?
So there are a set of ethical challenges. One is uh, you don't know the innovation that's going to happen, whether that innovation is for the benefits of the humans for a select few, whether that innovation has biases in it or not. So those are the challenges which are always there. Then whether that innovation is specific to a particular region or a country. For example, let's say an agent in an LLM is trained specifically on a data which was more coming from the US, from Canada, or less coming from, let's say, Japan. So there might be skewed innovation that may happen. And that's the challenge that is there. Also, the ethical part of it, you never know that because everything is based on the data. There's no human involved in the, or I'll say a very less involvement by humans. So that's why that there is also an ethical challenge, whether that's based on how the society is moving and improving.
So there's one more question. What new skills should students learn to work with agentic AI in the future?
Sorry, please say it again. I missed your question.
What new skills should students learn to work with agentic AI in the future?
I would suggest there are frameworks now with OpenAI, Crew AI, or with even cloud providers like AWS is coming with already has a Bedrock, or Azure has Azure AI Studio, and Google has Vertex AI. I think uh, try to adopt one, use that framework to learn, and there are tutorials available. So adopting one such is going to be the best way to learn and then start improving.
Thank you, sir.
Thanks a lot. Wishing you all the best.
Thank you for this wonderful session. Um, Thank you so much, sir.
Thanks a lot. Bye.
A very good morning to all the distinguished dignitaries, respected professors, ladies and gentlemen. At the outset, I, Tejaswita Singh, express a warm and respectful welcome to the 16th International Conference 2026. Recent trends in artificial intelligence and data sciences innovation, cybersecurity, AI and digital forensics, and advancement in IoT. Networking and cloud computing organized by Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with strong foundation and platform for the empirical inquisition. With this agenda, Conference 2026 intends to bring together professionals, academics, industry experts, research, and enthusiasts to discuss various emerging trends and innovations, share research results and new directions in the field of the next generation technologies.
May I now invite our keynote speakers to please join us on the stage. Professor Dr. Takaki Goto, Mr. Keith Sheringham, and Professor Dr. Narayan C. Devnath to please join us on the stage. It is now my honor to introduce our first keynote speaker. We are delighted to welcome Professor Dr. Takaki Goto, Associate Professor in the Faculty of Information Sciences and Arts at Toyo University, Japan. Professor Goto earned his PhD in engineering from Toyo University, and his research interests include software engineering, artificial intelligence, Internet of Things, data analysis, visualization, graph grammars, and software development education. His work focuses on AI-driven software comprehension and intelligent data-centric systems, and he has proposed innovative solutions such as LSTM-based forecasting for operational resource management. An active member of the international research community, Professor Goto has served as conference chair and program chair for several prestigious conferences and is a member of IEEE, ACM, IEICE, IPSJ, and JSA. May I now request Professor Dr. Takaki Goto to kindly address the gathering.
Yeah. I need to use this computer. Uh, okay, okay, yeah. I will use username and memory to transfer. Online के लिए ये क्या चल रहा है? Online अभी बैठा नहीं है, ऑनलाइन चल रहा है। It will be fine, sir. तुम्हारे कहने से बनने उधर फैकल्टी से आराम से बात करो तुम इससे बात हटाओ हटाओ हमसे बात करो मैं नहीं ऐसे नहीं करूँगा तुम्हारे कहने से हाँ तो मैं फैकल्टी से बात करूँगा मैडम से बात करूँ बात करूँ हमसे हटाओ हमसे बात करो what is the problem? Just. जी जी हाँ दो मिनट सर हाँ सर देखिए ऊपर देखिए do all of them our own laptop. Online. Just forget about online. Just put it online. Online is finished already. That's enough. Keep the whole online off. Okay, is it yeah? Okay. Can I start? Good morning, everyone. Today, I'm going to talk about generation of knowledge graphs and ontologies using large-scale language models. Now, I'm Takaaki Goto from Toyo University, Japan. Now, first, I'd like to introduce myself, and I'm Takaaki Goto. My university is Toyo University. It is located in near Tokyo. The headquarters of my university is located in Tokyo area, but our campus is located in next to Tokyo, Saitama Prefecture. And my research interests are software engineering, visualization, AI application, IoT. And so far, I served some chairs, conference chairs, and so on, like HISA, CIT, ICSA, Kane, and so on. So most Japanese are not good to speak in English, and me too. So I will do my best today. And first, I would like to introduce Toyo University. And I talked to several students, and most of the students are interested in Japan and the Japanese culture. It is very, I'm very pleasure for such kind of things. But I'd like to explain about my university. My university is founded in 1887. It's kind of a historical university, private university. And we have 32,000 students in total. And we have 15 faculty and 15 graduate schools, like economics, business administration, law, science and engineering, and information science and arts, and so on. My department and graduate school is information science and arts. And this is a map of Japan. And my campus is Kawagoe campus, located in the square area, the red square area. Let's zoom into this area. And this is the area called Kanto area. And the star mark is the location of our campus. And this part is Tokyo metropolitan area, and it takes about 20 miles, and it takes about 30 or 40 minutes by train. And it is a very convenient area. And Kawagoe City is located in Saitama Prefecture. And this is some photos of my campus. And now our campus is undergoing renewal project. And this is called Komorebi Road. Komorebi means light filtering through trees. And the left-hand side photo is a photo in last few months. But 2 months ago, that road was renewed like this, right-hand side photos. And also, the Faculty of Environmental Innovation will be established starting in 2027.
And this is a photo of some building in our campus. Like this, we have several buildings and clean and nice buildings. And this is a photo of a library. Of course, every university have libraries. And of course, we have library. And we in this building, we have some computer rooms in these buildings. And this is a photo of student hall. But this is not a big box, but it includes restaurant and some item shops. And compared to this big campus, our campus is not big, but our campus is located in countryside, so there are so many green and some spaces. And also, this is an example of cherry blossom in our campus. I heard from several students they want to see cherry blossom, and that's at that time I usually show these photos, cherry blossom photos, and in the March, end of March, and to beginning April, we can see such kind of very beautiful cherry blossom everywhere. But it continues just 2 weeks, so it is very restricted period to see to enjoy a cherry blossom. And also, I would like to introduce our city, Kawagoe City. This city is suitable as a day trip destination. Now we welcome so many foreign tourists now. So many of students, many of tourists goes to Kawagoe City, visiting Kawagoe City. And this is a historical city, and its main street lined with Kurazukuri, old building road. And this Kawagoe City is called Edo, Koedo or Little Edo. And in the city, there are some kinds of old buildings. So it is very good place for foreigners to go around in this city. And this is famous symbol in Kawagoe City, Toki no Kane. This building includes some kinds of ring. So I'm to move to the today's topic. Today's topic is generation of knowledge graphs and ontologies using large language models. So first I talk about knowledge graph. As we know, AI is progress is very faster, and knowledge also important for these years. So a knowledge graph is a representation of the connection between pieces of knowledge in a graph structure. And this is used as a database that forms a foundation for intelligent system development. The knowledge graph represents a relationship between entities and such as things and events in a graph structure like this. And this is an example of knowledge graph. In this knowledge graph, there are some information, and the circle means data entry, and the edge means a relationship between nodes. In this example, professor teach Java. There are some information described in this type of graph structure. And the graph structure is very useful to produce and also analyze. So knowledge graph, knowledge representation using graph structures has been employed since 1960s. So they have a history. And in the 1990s, semantic web technology was proposed, and the standardization of related technology progressed. And semantic web also is important and was proposed in the past. In the semantic web, knowledge can be described and published on the web using a data model called RDF. And in the 20s and 2000, the Linked Data Initiative, which publishes data as web content in an interconnected format using semantic web technologies. And in RDF, all data is expressed as triples of subject, predictive object like this. And this is an example. And yeah, focus on this area. Toyo University, this is a subject, and arrow indicates country. This is a predicate, and the other side circle is indicates Japan. This is object, and we can describe the information like this format. And the next is Google Knowledge Graph. Google proposed this knowledge graph, and the linked data published as open data accessible to anyone is called linked open data, and it can be used as open knowledge graph. The Google Knowledge Graph was proposed in 2012, and the Google's knowledge graph is used for web searches. For example, this is an example, and when we search items using a keyword, we can see the information in the right-hand side like this. And the red square part is knowledge panel. This shows some useful information. And for example, this example, this shows some categories and also attributes and the relationship to other knowledge. This information cannot be searched by a keyword, but this information can be generated by a knowledge graph information. And this is another example, the search query, Barack Obama's education. And after that, we can obtain such information. And top of the page, we can see the information like this. Knowledge graph was used to return the related institutional entities that Obama's is affiliated with through the links indicating has affiliation. To clarify the meaning of knowledge represented as a knowledge graph and use it appropriately, it is important to standardize the way knowledge expressed. And also, knowledge means such kinds of information, but ontology is also important to process knowledge graph effectively. And ontology is necessary to define how a knowledge graph is represented. And in knowledge graphs, ontologists define the vocabulary and also the structures. And in ontologies that define RDF representations, the following are defined: a class hierarchy, property hierarchy, constraints, and so on. And this is an example of defining ontology hierarchy in Wikidata. And this shows an example of the class hierarchy within the university class. And this is also showing that an example of the administrative division when it is located, a hierarchy used as a property. And the constraints on the structure of knowledge graphs are also defined in ontologies. A hierarchy representing the types of vocabularies, and B, the types of properties, and C is the types of resources. And also, RDF defines basic vocabulary such as class and property hierarchies. And the types of resources that can be used as subjects and objects of properties. And in OWL, details the constraints based on predicate logic are defined, such as constraints on properties that resources have as predicate, and the transitivity of properties. And this is an example of language used to describe ontologies, RDFS and OWL. And the RDFS defines basic vocabulary, and the OWL indicates detailed constraints can be defined. And this is an actual case of knowledge graph. This is a linked open data cloud. And this includes cross-domain geography, government, and so on. And this can be displayed like this. And in the LOD cloud, datasets published as LOD are represented by round nodes, and the connections between datasets are shown by lines. So like this. but this is very complicated. But of course, we can extract information, important parts. Of course, we can zoom into this each part. And the next is Wikidata. Wikidata is a collaborative edited knowledge base operated by Wikimedia Foundation. And this is also useful data and services. And here is an example of Wikidata, and this is an example of information on past president of Toyo University. In this information, we can see name, overview, etc. And in the left-hand side, this means predicate, and the right side is object. Yeah, like this. And the next is DBpedia. And DBpedia is an LOD built from Wikipedia information. And DBpedia is semi-automatically generated. And because the mapping information used to build DBpedia relies on Wikipedia article, DBpedia has a larger variety and number of vocabularies and so on. And the next is use case for knowledge graphs, data integration using the knowledge graph. By defining the structure of knowledge graph that represent database and ontology, it becomes possible to handle data in a unified manner. And this is an example of Scholia, and this shows Charles Darwin's explanation. And this content includes a list of publication topics, course graph, and so on. And this is an example of a list of publication of Charles Darwin. And this is a visualization of a topic scores of Charles Darwin. And this includes such kind of information. And also we can get course network of Charles Darwin. Yeah, we can see a connectivity of authors between Charles Darwin and other researchers. And using knowledge graph as a knowledge graph base, knowledge graph shows a relationship between pieces of knowledge. And the knowledge graph shows a relationship between knowledge and represented in a graph structure. And knowledge graph question answering, answering using the knowledge graph is important. And it is possible to explain what knowledge is answers was based on. Knowledge graphs are also important to achieving explainable AI. These years, of course, we know deep learning has much power, but deep learning is kind of a black box type. So we need to realize explainable AI. And so I think it is important to use knowledge graph and ontology to realize explainable AI. And next is next graph, knowledge graphs and large language models. And in recent years, the application of large language models has been attracting, as we know. And the answers generated by language models may contain errors based on bias and stereotypes. And the large language models require a significant amount of time to train. So retrieval augmented generation RAG is used to address content not included in the training data. So next is large language models. So you probably know details about large language model, but I briefly explain about this. And as we know, you probably use tools based on LLM, like ChatGPT or Google Gemini. And the LLMs are advanced AI systems designed to process and generate human-like responses. And the LLMs built on transformer architecture utilize neural networks featuring on encoder, decoder, and self-attention mechanisms. And these models are pre-trained on massive data sets and can handle tasks such as answering questions, summarizing text, language translation, and sentence completion. And yeah, famous one is OpenAI's ChatGPT, GPT 3.5. Example, OpenAI ChatGPT has approximately 6 billion parameters, so huge parameters, and can process up to 4,096 tokens per prompt. So it is very powerful mechanism system. But there are some limitations, as we know, regarding LLM. And one is outdated information. LLMs are limited to the data they were trained on, making it difficult for them to provide accurate response to recent events or updates. And of course, there is another limitations regarding hallucinations. LLMs may generate outputs that are factually incorrect or nonsensical, and these outputs can be consistent, potentially misleading users. In the resource-intensive update, retraining LLM with new data requires significant computer resources and time. And the generated responses often lack citations, raising ethical concerns about explicitly identifying the original source. And also, LLM often provide generic responses and may not be suitable for tasks requiring accurate domain-specific information. And due to time limitation, I'll skip this slide. And also, in order to cover the limitation of LLM, RAG is useful. And here is the overview of RAG. And this is an enhancement LLM. The RAG is a technique that enhances large language models by combining information retrieval with text generation. And RAG can generate more accurate output. And this utilizes search process and generation process. And here's a key component of RAG, knowledge base, retriever, and generator. And yeah, and how RAG works. The user submits a query, and then queries forwarded to RAG. And the retrieve and generation are performed, and the response is returned, and the answer is displayed to the user. And here's the advantage of RAG. First one is improving accuracy and relevance. And the second one is customization. And we can put some restricted knowledge to the RAG. So this can be useful to improve accuracy. And also, we can put some knowledge to the RAG system, so we can customize data to generate useful data using LLM. And also, flexibility is also a good factor of the RAG. And expanding model knowledge is also possible. If we use RAG using a knowledge graph, we add some information to the knowledge graph, we can expanding knowledge. And here's the stages of RAG, indexing, retrieval, and generation. And here's the steps of the index stage, but there's a time limitation. I'd like to skip this. So next is a current status and the future directions of knowledge graphs and ontologies using LLM. And extracting structured information from large-scale text corpora and constructing it as an external knowledge base requires manual effort from experts. In the past, there are some activities relating extracting information and manage output data into some kinds of database, but it was failed due to some limitations. but now we can have much power and we can use much AI techniques, so we can realize much more result these years. In knowledge graph generation, so knowledge graph generation automated processing using natural language processing is possible. And sorry, time limitation, so I conclude my talk. But most important thing is manual operation should be removed, and we can realize some progress using knowledge graph and ontology and using LLM. LLM, of course, some limitation, but we can adapt LLM to improve automation to realize accurate knowledge graph and ontology. Okay, thank you very much for your attention.
So there's a question. How does the RDF help in representing real-world relationships like your university and its location? How does RDF help in representing real-world relationships like a university and its location?
Yeah, we can describe such relation. Of course, we need some resources, but there is a format to describe the information, RDF or OWL. So we can put information to the format and the data. Yeah.
Thank you so much, sir. Presenting the memento. Betty. So we have a memento for you.
I request everyone to please move to F1's seminar hall.
क्योंकि कुछ लफड़ा हो गया बहुत।
Yes.
Hello, sir. How are you?
Good.
We met last year.
You going well?
Yes.
How are we going? Good, good.
Good.
Do you know where we're going?
Yeah,
So I'll follow you, yeah?
Yes.
Try to give some opportunities for you. And I will talk about opportunities first, because the opportunity is more important than the keynote. And we don't need to, because we are already late, but I don't know how the schedule of this room. We don't need to spend a lot of time asking questions at the end, because we are here. You can talk to us anytime. Okay, so with that, let's start. Now, let me tell you the slide that I really like. First few slides. Oh gosh. So I have been in the US for last 47 years. You did not born even at that time. And particularly, I was in this state. This is the state of Minnesota. So each of these is a state. So this is a Minnesota state, and I'm in the southeast corner of the state. It's a beautiful state. The reason is we have 4 distinct seasons. So if you get an opportunity, come and see me over there. 4 distinct seasons that you don't see here. First is the spring, Minnesota spring. How do you know? Color of the leaves. Green, the light green color that means the new leaves just started in the tree at the beginning. So that is why it's a springtime. This is the part of the campus that I was in. Okay? Then this is summer, which is a dark green. See? This is the lake. And around the lake, there are 5 miles of walking and jogging place that I used to jog all the time. See? So, and this is the lake, beautiful. In fact, there are 2 lakes, and this is also part of the campus. Next comes the best colorful leaves, fall. Can you see the suddenly you have spring, summer, suddenly all the leaves changes color, and this is how beautiful it looks like a picture, right? And on the back side is Mississippi River, which is very well known. So this and my campus is only half a kilometer or less from the Mississippi. Beautiful river. Okay, so after that, all the leaves fall in 2 weeks. Get into winter. Each of them is beautiful, unique, and we enjoy every one of them. It's a very cold state, and the winter is longer than other seasons. Okay, so that's why they're active in sports. Okay, so this is my Minnesota that I have been for a long time. Now I moved to Vietnam. Excellent country. Some of you, when the last year they went for 2 months, they enjoyed. And so this is a beautiful country. And this is the gate. The season in this is the southern part of Vietnam, which is different than northern part. So southern part of Vietnam, weather is same all year long. 25 degrees centigrade to 32 degrees centigrade all year long. This is another blessing for me after this long winter time. So somehow I got a chance to live in a very good place, very good country throughout my life so far. And you should take these opportunities in order to visit different places. We have Amity has a campus in US, and then they have been thinking about Vietnam, all these things, but you can always come because we have close collaboration. Let me talk about opportunities. You are probably all beginning level, but this is, you tell somebody who is interested, is that because we came to Vietnam to open a new school of computing and information technology. This is the purpose. Otherwise, nobody leaves the US. So I left and then built something new. And this, because I opened a new school, I have lots of positions open for teaching. So anybody that you know finished MTech are qualified, but PhD is preferred. But so anybody who has, like many of you may know that somebody finished MTech and working now in a private college, all this stuff, anybody can give information so that they get opportunity to come. Now, as we said, that candidates in all areas of computing, computer science, computer applications, information technology, computer engineering, all these are eligible. Applications are accepted throughout the year. There is no deadline. And so this is the email, my Gmail first, and take it if you like. Now, as I said, minimum qualification is MTech, MCA, MS, ME degree. Recently completed PhD degree will have the highest benefit in terms of salary, in terms of experience. And then attractive resources, international experience. either through internship or through position, doesn't matter. International experience is very important. And then competitive salary in US dollars and free furnished accommodation, free health insurance, excellent research lab. We'll talk about this, AI lab, cyber security lab. And then we have many other labs. Industry 4.0 lab, where the Amity group went last time. And so then we have funding. So this is the email in case you are interested and you communicate with me that you can do. Now, this is a research opportunities. When you are working with your advisors in BTech project, MTech project, whatever, and want to publish papers, then talk to all your advisors. They know my information, or you should give my information, so that when you finish a project, you can publish. This was the purpose of the MIT group who came last summer, that the purpose is you stay 2 months, work on the at least a paper, and then we will figure out to publish 2 papers, one for conference, one for journal. Nobody can guarantee all these, but we can. And that is why that's what they do. So, and you don't have to finish all the writing paper. You just finish the work. So when you come back, you can finish the writing papers. Okay. So this is, and then we have 4 conferences in the US. That's where you will see me all the time. And then we have journal. So we have everything that you need, and we can give all the opportunities to MIT students. Therefore, this is why you should take the advantage of this and listen. You see, even I said that I know who is talking, I know. There are 2 of you come here on the front desk, front row. Come. Yes. And next. Yes, sit there. Green shirt, green jacket, come here. Similarly, he's putting in something in his ear. You see, I'm fairly. I want you to be disciplined, because I am, by the theory, an honorary professor of MIT. You are all my students too. I am not outsider. So don't do something that we don't like, because that gives wrong impression to the real outsiders. Do not think you are too smart. We know, looking at your face, who is listening, who is not listening. This is what we have been doing for 45 years. Looking at your face on the first day of class, I can tell what grade you are going to get. And when you talk, what happens? You are disrespecting the teacher. This is what is happening. How can you do that? And your teachers are not telling that to do. I'm spending unnecessary time for my keynote. Okay, so these are the research opportunities in the US, journal, conference, publication, all these. And you need all these BTech project, MTech project, and all this, definitely. Okay, so anytime you contact me, as long as I'm here. And this is the website for the society that you can see all the information. Okay, now let's go to the keynote. The keynote will be less short because AI is everywhere, nothing new. And so this is a I will talk about quickly selected applications of AI, which you already know. AI in and cybersecurity, limitations of software development. So this is an AI, current view of AI, which is new, because initially was AI, machine learning, deep learning. Now generative AI went inside. And towards the end, there are many other AIs that are coming up. They will also change this diagram in future. Okay, so this basically says that AI alone or in combination of other machine learning, deep learning, all this, and pattern recognition, computer vision, blockchain, are helping software development industries to build intelligent applications. Now, you are in the industry or in collaboration with academics, that's what you can do something more. Okay, so so AI is making revolution. Now, as I said here, that AI is expanding, like I just said, so, and it will expand a lot. Now we have application in education, which is voice assistance to improve students' learning. We have AI e-commerce, AI-powered assistance for natural language and fraud prevention. In navigation, you all use GPS. So in agriculture, it's the good application which I like, because EIU, not EIU, AUE, Arab Emirates, United Emirates, Arab United Emirates, full of sand, nothing is there. But as soon as you dig the sand, you get oil. That made them rich, correct? But now they never had agriculture before. Now they are making an agriculture in the middle of that sand. So this is because of AI application. So AI, computer vision, robotics, machine learning helps identify defects and nutrient deficiencies in the soil to improve food production and farming. And that's the advantage they are taking, because they have money and they are taking all the AI tools to do. So I call that they had the natural oil that Allah gave them. Now they have virtual soil that AI gave them, making them really rich and productive in the world. So this is, and then we have the automatic vehicles and all this, which is coming up very fast, and everybody likes it. Self-driving vehicles and all this, which I will not do, but you can. Robotics, there are many, which is very important applications. And Japanese are top in the world. So robot manufacturing industry, agriculture industry, mining industry, healthcare industry, a lot of this. So the healthcare and medicine, remember that we had COVID. Because of advanced AI research recently that we have, we survived, the whole world survived, not just India or US, because we created a vaccine in 18 months that normally takes 18 years or more. That was the blessing from God, that the whole world survived because of AI application currently. So this is so COVID-19, all this advanced research. Then this is the top 5 healthcare things, which is very important applications. And so the robotic surgery and chatbot and virtual nursing assistance 24/7, all of those things helping us significantly. So the use of AI in the healthcare industry is radically changing the face of information technology. So industry and academic collaboration is significant. And that has to happen, that will happen, that is what is happening now. And you should continue to do this. So then this is AI in HR, the human resources. All that is very useful now in the US, where AI fits in HR. All the recruiting, learning, onboarding, engagement, all very effective now because of AI. Significantly helps time and process. Next, this beautiful lady come in, is that AI and evolution of mass communication, AI in mass communication. This, and the lady was created by an Indian professor in the US to do the TA, teaching assistant. So when the students have questions, which they do all the time, they immediately ask questions anytime, 24/7. And this lady answered the question. First 5 months when it started, students even could not realize it's real or virtual. It is that good. And so now this, remember in the US, in India, you have 1.5 billion people. Every university has tons of students. In the US, we beg students to come. The reverse. The reason we have lots of universities, competitive, students are not as good like you guys. Indian education system is the best. But what happens that we have to focus on two things: recruitment and retention. Here, you come directly help recruitment process automatically. They don't have to care, but we have to care to recruit. That please come. Why? Because we have a beautiful garden, beautiful parking lot, all this stuff. Not beautiful education. Education comes next. You have to give the facilities that, hey, this is all the facilities we have. You see, MIT does the same thing, but they already have by default the number of students that they need, or in fact more. So in any case, so this is the robot stuff, and then the ladies. But then, because of AI, we can create a dynamic curriculum instead of static curriculum. You have three curriculum: data science and cloud computing and all this stuff. And so here, now we can create a dynamic curriculum. Anybody can like any curriculum that they want to be, based on the pace and interest to enhance students' engagement. Okay, so this is all is application. Now, so far, these are all nothing new, everything happening, and it will continue to happen. But now we are going into what is challenging application. Coming now challenge more and more. First is that we have empowering millions of students and staff with disabilities. You cannot even recognize or realize the world. Those is what we want. We need AI powered, a next generation AI, which I will talk at the end, along with new and advanced AI tools and technologies will bring a smarter and brighter society in the near future, because we want to give the same opportunities to the disabled students somehow as the normal students. So AI, and because of that, there are a lot of conferences also. So at the end, it says, important note, is current power of AI enough? See, now that should make you think, what do you mean? We already have a lot of AI here, there. Now we are saying something that current AI cannot provide. That's the first challenge. Now, then this is another one. Very important example. We have a lot of brain samples in Denmark. And those brain samples came from psychiatric evaluation of psychiatric care. With psychiatric patients, all the brain samples are collected. Question is, now we have data. How do you use that in order to create drugs and future treatment for mental health patients? For example, researchers believe that this advanced study may help improve patients and with dementia, Alzheimer, Parkinson's, and all of those. So this is what we need. Again, the current this brain research on psychiatric evaluation requires sophisticated supercomputer and highly effective intelligent software technology. We don't even have. So we have data, no algorithm to implement. So now, mission ahead, there are a lot of things. We can have soft robot, which will just automatically create shapes and sizes. Hey, what happens here? Don't worry about it. We are used to this. And then making human milk, operating with holograms, sleeping smart on, and then Tesla's technology you can use for electric boats. That's not a problem. So AI and machine learning applications in many areas is happening, and then that's what we already see. The question is, when I came, we see in the US for last 10, 15, 20 years, AI and cybersecurity growing together, suddenly. Came from originally from software development, software engineering. So then it's growing rapidly. Now the question is, this is when I came to Vietnam, I created AI lab so that whole world can come and join us and take the opportunities, the resource. Of course, you have everywhere, but still. And then these are some of the applications that you quickly think about this. And then if you come, you can do in any area of interest. Okay, next. These are some of the active projects: traffic violation, social distancing alarm, and then skin disease. We cannot compete and give opportunity to students if we have only AI lab. We have to have cybersecurity lab because two areas are going in parallel, you see? So this is in collaboration with a company in Japan, Aris, we created a cybersecurity center. And the reason was raise awareness of cybersecurity through seminars and training programs, provide hands-on experience and all this, training for industries. These are the important things. These are some of the curriculum anybody can develop on cybersecurity. The courses on computer security, web security, network security, digital forensics, and all of it. Now, you see, that room was better because that had water and glasses, and now he has nothing. Anyway, let's keep on going. So these are the research on cybersecurity, malware detection, malware analysis, penetration testing, digital forensics, incident handling, and of course, attack detection, prevention, and all this. So this is this. Now, question that we now will come most challenge that we have users. Whenever they have the iPhone 75, they say, I have everything, man, then nothing else. And of course, it is the most powerful machine you have compared to what you had before. So now, but computer scientists, on the other hand, believes, do we really get what we want? For example, I already said, disability people, we don't have enough power. We have the soft robot things we cannot create. And then there are many things that we don't know. The brain-related research that we need cannot do. So all these, the question is, this gives you opportunities. Then we are now focusing on software reliability, that how reliable a software can be. And of course, there are many reliability issues that you can study. We don't have too much time. It depends on all the phases of life cycle that you can study in your courses. And then finally, most people are trying to test whether intelligent software, normal software, or any software. The testing is the most important to find reliability, and we want 100%, which will never be possible. That's the challenge. So this is because the error, we have errors in the program, and error propagates from one phase to another, creating tremendous number of errors, and we don't know where they are, how many they are, cannot fix. And even if you fix, create a new program, that causes another problem. So all this, and what we expect and what we observe, different. Then we have, when we do the testing, you see that when you observe specified behavior, observed behavior, testing of the behavior, it doesn't intersect. In order to help that, we need to increase this. So now, all of this happens. We have different types of testing. Let's say conclude this. The field of software testing wide open, challenging, exciting. That basically comes from software engineering. Doesn't matter what kind of software it is. Only thing now with AI, the softwares are much complex, large, and difficult to do. So first need collaboration, and Amity is very good at it. Collaboration. So then there are three types of AI: narrow AI, general AI, super AI. We need to go from one level to the next. We are still, when we say, do we have enough? Answer is completely no, because we are still in stage one. But many of us think, oh, we have everything, AI everywhere. On the other hand, so this, in terms of continuous progress in computational intelligence in general, is a long way ahead, and you have lots of opportunities in the future. So this is the AI is offering actually innovation. On the other hand, cybersecurity is destructive in nature because it tries to attack the system and cause harm. But the positive part of this can be used as a testing, because it is attacking a system, you need to create a better system in the future. Two, so that cybersecurity cannot easily attack like now. So now, where did the well, remember that they both depends on intelligent software development process. The algorithms are complex, and that is why they are similar. So now, so we basically now see that Some people say, hey, the cybersecurity guys are really doing bad thing. Possible. On the other hand, they are actually help improve the system if you look. And so the is that we have to use the system effectively, responsibly. And that's what this is, that it depends upon our ethical behavior, whether we use it or abuse it. Use AI, abuse cybersecurity. But there is no, you cannot say one is bad, one is good, and all this. So now this use versus abuse, change versus progress, destruction, creation, all this goes together in order to help the society make progress in the future. So so that comes next, immediate next AI is the ethical AI, which is growing fast. And that is what will add the dimension of that whole AI. And then there are many AIs that you heard in the keynote, agentic AI, that AI, this AI, all this, a lot of the AI that will eventually. So what is happening, we are growing horizontal. Lot of AI types, but we need to do vertically, narrow to general to super AI. Super AI, when we will have the right and the best society in the world, which will take many, many years. That shows that you have lots of opportunities to do. But only thing that you need to do, constant education, training, and self-awareness to look forward to make sure that we are creating the right society with the right progress. Okay, so this is the future of mankind. And that's the end. Thank you for your attention. We are already late. I will be here throughout the day. I will hear it. Anytime you want to have question, answer, just stop me and ask question. Because we are simple people, not very advanced VIPs like average people. So you can talk to us at any time. Yes, I agree, absolutely. Okay, thank you so much.
Thank you, sir, for your thought-provoking and inspiring address. It gives me immense pleasure to introduce our next keynote speaker. We are honored to have Mr. Keith Sheringham, a distinguished technology leader, author, and a fellow of the Australian Computer Society. Mr. Keith has delivered high-profile business transformations for executive and senior management across global organizations such as EY, Citi, Air Indigo, Qantas, and other leading Australian companies. He is a noted author and speaker on the business applications of information and communication technologies, including artificial intelligence, having authored over 30 research papers and several books. He also serves as a reviewer for reputed publishers and journals, including CRC Press, IEEE, and MDPI, including the Journal of AI. Mr. Sheringham is a company director, a director for not-for-profit organizations. His association with India includes guest lectures at universities such as Shiv Nada University, KPGU, the Institute of Information Technology and Management, along with collaborations with the Indian Computer Society, Power Engineer Society, and Rotary Clubs. He has worked with developers in Vadodara on an award-winning community platform and is currently involved in a tourism platform for the municipality of Vadodara and the government of Gujarat. He has also collaborated with major Indian IT service providers such as Tata, Infosys, HCL, and Tech Mahindra across Mumbai, Delhi, Bangalore, and Chennai. He recently advised the Sarawak government on a statewide AI solution, including data governance and implementation, and has consulted for the New South Wales government on artificial intelligence assurance. May I now invite Mr. Keith Sheringham to kindly address the gathering.
Thank you very much for that introduction. I'm not able to compete with the power cuts and the thunderstorms, but let's give it a good go. And Prof, thank you for your talk and talking about some of the challenges and business opportunities and education challenges around AI. We're going to carry on with that theme. If the power goes out and the lights goes out and the slides go off, I'm going to come to people in the front row and get them to tell us a funny story. Yep. We're not recording the session. Thank you for the lovely introduction. So I want to do a quick introduction to the session, trends around AI, talk about some next generation AI, and then wrap it up. Given our sort of timing, we're running late. I'm not going to ask you lots of questions and be as interactive as some of the sessions. And would the host please keep me to about 20, 25 minutes? Thank you very much. So I want to do a couple of key concepts. As a business, I need different types of AI. I need my IVR. I need my chatbots. I need my robotics. I need my generative AI. And I need them to integrate together and work together. This is a gap in the market. Now, some of the other AIs like robotics and facial recognition, this issue of integration has been resolved, for example, passport control at the airport. This integration of AI types is a gap in the market. And so if you're looking to do your startup, there's an opportunity there. Now, AI is still going to be standalone over here, and I'm still going to copy and paste out of generative AI. But the big trend is it's just embedded in devices. It's just embedded in my mining logistics software. I don't care about AI yet. I just need to schedule my mines and logistics, and that's it. Again, we're starting to see AI embedded in chips. Yep. We're starting to see devices that the new Dell laptops track everything. I'm not sure about that, but they're using AI. I want to cover off a quick couple of concepts. We need to treat AI as a user of data. And with that comes accountabilities, liabilities, and responsibilities. It's not like running payroll, yeah? It's not like a document management system. Park the legal, which is a big area of opportunity. As a business, if you start to treat AI as a user of data, you can manage it and realize the returns. Of course, if you get bad data, we get bad AI. And data is by far and away one of the biggest issues impacting the take-up and use of AI within business. Right. Nothing happens without budget and resources. Yep. So we're not just going to transform around AI. Management has to make decisions. You have to take time away from operations to do it. Sovereignty is going to become a big issue. It's already starting to become an issue, and we'll talk about it more as we go through. Now, I am in no way advocating that anybody uses any of this conversation to commit crime. But we will talk a little bit about cyber and we'll talk about crime. And if there's one job that is not going away, it's cyber and related activities. Right, let's talk about some trends in AI. Business needs many AI types. They're integrating the AI types at different speeds and different ways according to business needs. Please park all of the hype you hear around AI. AI is evolving rapidly, it's moving, it's heading in that direction. But the proven pragmatic business realities apply and kick in. We're hearing that the investment returns are not being realized. I'm sorry, if you've had robotic software with AI and Japan is the world leader in that, the investment returns are to be had. And they're there now. We've talked about the integration, we've talked about the data issues, and one of the biggest ones is taking us on the journey to use AI to skill up. As a 21-year-old, you've grown up with it, you're much more responsive. Me, being the other side of 50 now, I'm a bit of a laggard, but I still use it. Now, markets do what markets do. They operate in a dysfunctional, chaotic way. We operate in a market economy. Some countries don't, but we do. All of the hype around jobs, losses, and that sort of thing, at the moment, it's not being seen. Yep. And we'll talk about that as we go through. A lot of the cuts in jobs attributed to AI, it's nothing to do with it. It's just basic corporate profit and loss. The human role is going to be more important as we progress with AI, not less. The regulatory regime is going to kick in. We've already have problems with imaging and creating pedophile porn. We already have AI-driven suicides. AI companies are already being prosecuted, yeah? And we've already had toys pulled off the market because when you talk to them, they say insensitive things back to children. This is just part of us managing it through. Investments we won't get into, we don't have the time. Now, the reality around generative AI and agentic AI is that 95% of pilot projects have not delivered the returns and they've not scaled. And we'll talk about that as we go through. Now, that's not to say AI isn't going to be transformative. It is. We just have to be pragmatic about it and ignore the hype. Now, I want to spend a couple of minutes on this world map. Who thinks the US is the world's leader in AI? Anybody? Okay, it's a loaded question, but thank you for putting up your hand. There is some US leadership in generative AI and agentic AI. Okay, who is the world's leading country in robotics? Japan. Prof, you can comment on this much more than I can. Which country is the leader in the use of AI in food production? Holland. The Dutch have led for years with factory warehouses producing food. The robot plants the lettuce, comes along the next day, spritz it and gives it some nitrogen, comes along a week later and harvests it. The United Arab Emirates was the first to have a minister for AI and an agency for AI. The Ukraine obviously leads of AI in drone warfare. India is the leader in ethical and inclusive AI. Yep. Australia, we're a laggard in most things, but we do lead in indigenous AI and culture protection. Now, Europe is obviously leading in data protection, but what I want you to note is how many arrows point into China. It leads in the integration of AI types. It leads in specialist algorithms. It leads in energy efficiency. It leads in imaging and facial recognition. It leads in the skilling of people. So if you think the US is ahead and you can't compete, you're wrong. I want you all to start your companies and those sorts of things. Now, there's two main approaches to AI. I'm going to call it the American model, but Americans, please forgive me on that one. America's going down the path of one size fits all. It's doing massive data dependencies, massive data centers, massive complex models. It's not doing much testing, and it really doesn't care about the regulatory side anymore. And we're seeing the good and the bad. Every other area of business endeavor, the one size fits all seldom works. Now that the market will prove it right or wrong. But if you look at nearly every other country, they're looking at sovereignty issues because India's sovereign needs are different to Singapore's, are different to Japan's. They're looking at the business integration. They're looking at specific models for servicing specific things. I work in a bank. I do fighting financial crime. My AI doesn't have to write a Harry Potter movie for me. Why do I want that? It's embedded in devices, and the rest of the world is worried about safeguards. The UK leads in some of the protections. China, very different political regime. China is the leader at the moment going down this path. It's taken a very different approach. Singapore went through its entire economy and looked at what data it has, what data it needs. Does it have sovereignty ownership? Should it reside in Singapore, or are they happy to put it in an American cloud? When we talked about this last time, and you were going down the same path. Europe is pulling data out of the cloud back into its businesses, and it's building its own cloud infrastructure because of the changes in geopolitics. So again, when you say the US is all-encompassing, it's not. Let me skip over that one because we're running out of time. Cybersecurity, everybody's talked about it, growing demand. We'll skip that one. Let's talk about some emerging trends, because you are the ones that will implement these. You are the ones that will make the money out of it. You are the ones that will grow society with it. Obviously, the investment in data centers drives the economy. Now, the issue with data centers is this: you need data centers outside of AI to meet the growing economic demand. China leads in energy efficient data centers. China leads in building data centers where there's water and power supply. America is the opposite. The market again will dictate. We've talked about data and how important it is to the economy, Prof. You were talking about that as well. You need sovereignty over your algorithms and your models. And I don't care whether you're doing large models, small models, specialized models, doesn't matter. You've got to have control over it. The models that you're going to use in your fighter aircraft are going to be different to the ones that you use for medical care. Yep. So again, the one size fits all, I don't see it. We've talked about embedding in chips, and we even talked about embedding in devices. We obviously have to fix the governance, and we have to sort out people. All of this is the opportunity. So I don't care whether you're doing skilling and training services to tuk-tuk drivers using AI to navigate Delhi's traffic. The market is huge and the opportunities are there for you. Some of the emerging areas are real-time decision-making, having context to what the AI is producing, managing errors and exceptions, and managing business processes. We will share the slides at the end so you can go through in more detail. Now, one of the things with business is you need consistency in your products and services. Some of the shortcomings in the current AI and the current models is that they're continuously changing. And that's good for some things, but for other things, it's a big no-no. So we need to get the processes sorted out. We need to get the data. We need to get it provisioned. We need context. And again, we need to sort the governance out. Now, sovereignty over AI is a big issue. Sovereignty doesn't mean that you build it. Obviously, there's benefits from India having its own sovereign capacities and capabilities. You need to control the interfaces. If you have control over the interfaces, you have control over the component parts. So you don't have to build everything from scratch. If you focus on the interfaces and the integration, you can have control over it. There's whole areas of emerging areas like benchmark testing, real-time decision-making. We've covered that one. There's a whole plethora of new knowledge worker services that are coming out of cloud, like project management, testing as a service, that sort of thing. And things like tax, audit, legal, all of those knowledge-based services move to the cloud using AI, which you just consume. Now, I want to, how are we doing for time? We've got a couple of minutes, good. Please note the flag on this slide. I am aware of the friendly rivalry between India and China, and it's done for a reason. Yes, We need information as a service, software as a service, database as a services. We have to support legacy. As a global bank, it is too expensive and too high risk to replace a legacy system. But we need to get the data feeds in, extract the data, and use it in AI. The current AI is not good at this. Again, another gap in the market. Obviously, we need a new generation of interfaces to link the systems together. The current ones work, but to meet the need over the next 10 years with what's coming down the track, we're going to need a new generation. So these two gentlemen here behind Prof, excuse me, gentlemen, this is your next business, yeah? We talked about the integration of AI types. Handling errors and exceptions is obviously a key issue, especially within the current one AI. Permissions, access, authentication, those sort of things. We'll talk about profiling and encryption. You have to have your data encrypted beforehand, within AI, and after AI. There's a growing market in hacking into your AI models, corrupting your data so that the AI gives you the wrong answer, corrupting the AI so you can't use it, and then wanting you to pay up in crypto. And if this is happening now, you can see the opportunities in the market, and this is why cybersecurity is not going away. Now, I'm not a techie guy, as you can tell. Keith just doesn't dream this up at night. China is going down this kind of layered solution approach. Forget the technical bits. They're embedding encryption within their AI. If you look at the American models, they don't. So the data beforehand is not secure, the data in AI is not secure, and the data coming out is not secure. This is the opportunity for India and for other countries. Australia, we're equally negligent, I have to confess, but this is the opportunity. This is the market, okay? Now, somebody said to me, Keith, if there's one piece of AI technology that you want, what is it? And I said, I don't want it, but we have to have it. And it's personality profiling. If AI enables me to say exactly the right thing at exactly the right time to the right person, I can get you to do things. Wouldn't that be way cool on your app? Right. When we did the layered one, we had profiles in here. The profiles know who you are, what you're doing, why you want to use the data, what you're doing for, and all those sort of things. This gives it context. This makes it relevant, applicable, and all of those sort of aspects. Now, with profiles, there's the data. You're going to have to know about my personality traits, my emotions, what hat I'm wearing in what workflow, those sorts of things. And you need to know the safeguards and that sort of thing. We need to be able to manage the escalations, the emotional response versus the logical response, enabling innovation, and all of those sort of things. There's a whole set of pros and cons and a whole set of challenges. But if AI is to actually deliver what we're looking for, we need profiles. We're starting to use it at the very edges, but it's very primitive. But again, if India wants to get ahead of the curve, the Americans are not serious about profiles. China has started down this path because of its legacy and the way its government works and that sort of thing. But again, it's a big opportunity. Let's moving on, and conscious of time. Now, we know the errors in AI come from insufficient data, incorrect data, the assumptions in the model, biases in the data. One of the biggest factors is the human instructions. I gave a similar talk 2 days ago, and I said, "Hey Siri" into my phone, and it actually worked and came out with, "Hey Keith, you don't have to say, hey Siri." So that's an example of me. There we are. See, Siri's come up on the phone. Now, nearly everything we do is a process. Yeah, it's a repeatable process. I'm manufacturing cars. It's a highly structured, repeatable process. I'm processing tax returns. I'm processing mortgages. It's a repeatable process, a little bit of fluidity, but there's set steps, set things to go through. Our agentic AI and our generative AIs need this repeatability. Yep. And this is a challenge. Now, AI, we can use checklists and embed errors, exceptions, and all of those sort of things in our AI, which we're going to need to do. But I want to give you an example. Who here has a credit card? Who here has a loan? Or has ever gone to the bank for a loan? Anybody gone for a mortgage? What's stopping you? You should own 5 houses by now in Delhi's booming real estate market. If we use AI in processes, we say, AI, is Keith going to be able to pay his debt, and should I give him the loan? We move to an outcomes based. At the moment, you fill in all the paperwork and they look at your assets, they look at your funds, can you pay? And then they probably decide on that. Given the data, they can look at your payment history and say, even though Keith doesn't have much money, he's paid his bills every day for 10 years, he's a cool guy. He can say, oh, Keith's living in Australia, he's applying for a loan in Delhi. Not so sure. Look at what's happening in the market. We can now discriminate on age, class, race, gender, you name it. So Keith is in a Muslim country from Australia. The bank thinks, oh, you're not a native. Yeah, I'm not going to give you the money. And of course, we're back to personality profiling. Whether we go down this path doesn't matter. It's an example of how we move to an 8 outcomes-based approach with AI and what AI would have the potential to do. It's how we decide to manage it and how we decide to apply it. That's the issue. Quick one on this one. Who's heard of vibe coding? Yeah. Who thinks it's cool? Who thinks it's a load of rubbish? It's somewhere in between, and it is going to get better. At the moment, I can get an agent to schedule my diary. I can get an email to pump out rubbish posts on LinkedIn. I can get an agent to go to a meeting and summarize a meeting that I don't need to go to. Why I'd want that one, I don't know, but let's not worry about that. There's a whole series of issues with agents, including cybersecurity. And also, Keith just uses the agent without any concept for the code, the data, and anything underneath it. So agents are good. We're going to use more of them. They're going to proliferate. But how are we going to use it? And sir, you know, with vibe coding, the logics of software engineering and good practices get missed. You spend more time debugging it and testing it than you actually, if you'd written it from scratch. Okay, I want to quickly talk about quantum computing. The US has said by 2030 or whatever it is, all of their encryption has to be resistant to quantum computing. HSBC has introduced the world's first standard for interbank banking with encryption. State Bank of India is rolling out a new generation of routers with the next generation of encryption within it. Yes, quantum computing is going to make things faster, new generation of models, new coding, all those sort of things. The impacts of quantum computing are hitting us now. We're starting to see the chips, we're starting to see the devices. It doesn't have to be real now. A bunch of nutters over here just has to convince people over here that they can break their encryption. Yep. Now, I'm not advocating I'm not advocating that that's what you do, but this is the commercial realities. So you can see how quantum is intimately linked with cybersecurity and how cybersecurity is interlinked with AI and how they feed off each other. Right, conscious of time, and I know we've gone through a lot very quickly at a very high level. We will share the slides so that they're available afterwards. Everybody, thank you very much indeed for your time and questions, comments. Thank you. Sir, what business are you going to create? Yes, the gentleman in the blue sweatshirt with the white stripe on his sleeve looking away from me. Sorry, sir, what's your name? Yeah. Yeah. Any questions, any comments, any feedback? Nothing? Was it boring? Okay, so.
When we talk about business, we have seen that America has invested for $110 million.
Yeah.
China is around $70 million. Australia is also facing up. In India, particularly, we see investment is very less. There are not many startups that are coming out. So they recently, last year, only in Y Combinator, there was only single startup from India. Where are we lacking, and why we are seeing the situation that our companies are not AI ready?
Right. It's a great question. I'm going to break it down into a couple of parts. There's some very good, solid investments in the US. There's some hype. We're seeing data centers that are full of servers, which are degrading over a 2-year period, which will become useless, that are not being used. It's markets do what markets do. China has the advantage of it has a government which is highly controlling. I'm not saying that's advantage, but it has a government that has a clear policy. And they've specifically set specific objectives. China takes a whole of business approach. It gives them loans, it gives them cheap land, it gives them grants, that sort of thing. It seeks researchers to go back to China. America's going down the opposite path. When we come to India, India's doing a lot of good things. Yep. Don't listen to the journalists at saying you're useless and you're backward. Ignore that rubbish. The government is working on a whole of government approach, but it's not a Chinese government. Now, your major tech companies like Tata, HCL, and TCS. I was in with TCS last Friday here in Delhi talking to them. They've grown incredibly fast and incredibly quickly doing low-end coding, low-end sysadmin. Their challenge is to keep the ship running, keep the business coming in while they move up the value stack. Yeah, that's a difficult thing to do in business. There are some very, very innovative leaders in TCS that get all of this, want to spend more money and want the company to go down the path. There's other ones that are less. Now, when it comes to startups, so there is a bit of a reluctance and a hesitation to change. When it comes to startups, it's not the technology where you come undone. I'm associated with several startups, and I've been talking to people in government and prof here and that sort of thing. The startups do not teach the business management 101. So 90% of IT startups fail because they cannot sell. If you cannot sell, you cannot get money coming into the door, you cannot get investment, et cetera, et cetera. I mean, you might be lucky, but basically you don't. Next one is management of cash flow. So a series of measures are going to be needed to boost the capacity and capability. Now, your minister for, is it technology or innovation, or I'm not sure what it was. I'm sorry, I forget. He was at the World Summit in Europe, and he said India is building data centers, it's building chips, it's building applications. He didn't actually say the gap, but your gap is people and data. When you can get the whole of government addressing all of those, you will start to ramp up. And at the end of the day, it's about you guys in the room. Yep. There is no reason why you cannot be leading in the integration of AI types. There is no reason why you cannot be leading in layered architecture. It's all the usual political factors, incumbency, and that sort of thing that come into play. And you guys, it's your future. The guys like me, we've sort of run the bunch of our race. We're sort of, if I was going to be the Prime Minister of the UK, I'd be of Australia, I'd be there. Now, you guys have the opportunity to shake it up, and this is what this talk is about. So I'm sorry that that's a long answer. There's no one simple answer, but it is for you. Have you got time for one more question, ma'am? Prof, do you want to make a quick comment, or are you all good? Good. Everybody, thank you very much indeed for your time.
Let me tell you, this reminds me, challenging 2 years of my teaching. I had, remember, like all of you, we had to treat every student who comes into the class equally, and we have to serve them. There was a time when I had a student who was blind. So he had a dog like this. So every day he comes to the class. He had a red stick in one hand, like this, when he walks. The other is the lace from the dog. Both, and the dog is his master. Dog is telling, suppose he's crossing the street. Dog has to make sure that somehow indicates that there's a danger. So it was very difficult to really teach a student who is blind, because normal lecture doesn't work. He cannot see. And many, like when I do a diagram, he cannot recognize what is this. So I had to completely change. Remember that there are other 29 students in the class, one student blind. And so every day he comes, the first time he sits on the chair like Goto is sitting, the dog immediately goes underneath, sleep exactly this way every day. And then I thought that if I teach one class, and so I had to change completely a lot of things. First of all, I gave him the lecture notes. Then he translated into some kind of things that blind people use, barrel or something. And so he had already that. But then a lot of things that I teaching in the class for normal students, I had to teach two ways. One is drawing the diagram, one is without. Sometimes in the table form, this kind of thing. That is what he has. So I thought if I teach one class, then I'll be done, right? It's very difficult. It takes 2 times the more work, but we cannot say, go away. Then I used to teach 6 top important courses. Some are elective, some are required. He enrolled in the next course again. I said, oh my God. So I had to do the same thing. Eventually, he took all 6 courses, which was a surprise to me, graduated. And then there was a American girl, his girlfriend. She used to take care of him a lot. Eventually, both of them were students. Both of them graduated. Both of them then got jobs. Eventually, they also got divorced. This is a life that we have gone through so much. But I'm saying that the dog is sometimes very helpful. But so before all of you leave, make sure the dog is out, because otherwise it will be stuck in this room. Okay? So some of the times that we do our profession is very challenging, but rewarding. Okay? Thank you, Prof.
Thank you, sir, for an exceptionally informative and forward-looking keynote. May I invite Dr. Betty Paulraj, Assistant Professor of Amity University Engineering, Amity University, Noida, to present the mementos to our esteemed speakers. Dr. Takaki Goto. Dr. Takaki Goto, please join the stage. Professor Dr. Narayan Devnath, please join the stage. Mr. Keith Sheringham, please join the stage.
Thank you, everyone. If you've got any questions, just come up and see us, and just try and grab us throughout the afternoon if you need to as well. Thank you all for your time. I appreciate it's hard sitting there listening to us ramble the whole time, and I'm sorry I wasn't able to do more questions with you. So.
Excuse me, can you guys hear me? Hello. Excuse me, can you hear me? Okay, I'm Rahul. I'm giving presentation on the payment modernization agent AI. So good morning, afternoon, everyone. Thank you for this warm welcome. I'm here. I'm really appreciate to have here the Confluence 2026 as a keynote speaker. Yeah. Today's keynote focus on the payment modernization age of AI, specifically in the journey, right, from the batch processing intelligence system. So till now, we used to do a batch processing of the payments. Nowadays, we are doing the intelligent and real-time payments.
Excuse
Most
me,
of
sir, we
us
can't
use the
hear you.
mobiles. Hello, can you guys hear me?
Hello, sir.
Yeah, can you hear me? Hello. Ah. Can you guys hear me? Hello.
Now it's audible, sir.
Okay, can you guys hear me now?
Yes, sir. Yes, sir.
Perfect. Okay, that's good. Let me start the presentation. Okay, so good morning, good afternoon, everyone. My name is Rahul, and thank you for the warm welcome. And really, it's truly pleasure to be here. I present the Confluence 2026 presented by Amity University. So my today's keynote focus on the payment modernization using the AI. So I just listening to Keith and Dr. Narayan earlier. So AI is being used. There are a lot of opportunities, and one of the places we use AI is in the payments domain. So I'm going to walk through it, where we are, how we are modernizing the payment industry, from the batch processing to the intelligent real-time payment. So batch processing is when in the decade ago, you might aware, you go to the bank, you transfer the money, and it takes a day or two to transfer the money from one person to another person. Especially also this in the banking for for the large organized financial institution on the service industry. Like let's say salary is an example. They created salary day one and it takes next day to create it to the employees. So that has been changing. We are using real-time payment. Most of you use your mobile for the scan and the QR code, you close the payment. That is part of the intelligent routing, including the batch processing. So that is what we are doing as part of intelligent routing, and also using AI, how that AI is shaping that particular industry. So payment platform must process the billions of transactions per second. Consider the population, how many people are using the QR code or maybe online banking for right? So this payment platform must, when we process millions of transactions, operate with real near-time zero downtime. We don't expect any downtime. Also, the meet the latency and also the prevent fraud. We don't want to get my payment to be fraud, right? This has to be a success. And also there are regulatory compliances for each country. So that's how all this happens simultaneously across the distributed environment. Because of this, payment systems have become a living example of how advanced computing, artificial intelligence, and distributed system and real-time data processes comes together into a practice. That is why the topics align strongly with what we had tracked with the Confluence. So let's get started. So why does the payment modernization matter? So what is the need? Right? So to understand why payment modernization is critical, we must first look at how the world around us has changed recently. There has been explosion of the digital and the real-time payment across the consumer, corporate, and platform-based ecosystem. So gone are the days when you go to the bank and use go to the teller and asking for money transfer, submitting a slip. No, now use your mobile phone, do a scan, and just doing the money transfer. That's how the evolution is, and that has exploded in last 4 to 5 years. Okay, people are expect payment to work instantly, regardless of the time, location, channel. Right. At the same time, we don't want any fraud risk, operational complexity, right, that have increased dramatically. Fraudulent people adapt very quickly. Exploding days are the blind spot are legally in the systems. So manual reviews and static rules applies cannot simply keep up, right, with the volume and velocity modern transaction. We don't want your payment to stuck for the manual queue. If you're making a payment and it's stuck in manual queue, you want it instantly, right? Any fraud check or any supervisor check of your payment, you want it seamlessly. So that's how the need of the modernization is. So this is where a legally batch process system, right, what we have has their own limitations. So designed decade ago, those batch system was not compliant with the current speed we are transferring the payment. So this challenge mirrors many real-world systems like modernization of problems where advanced computing techniques are required to replace the architecture that is no longer matched today's demands. That is what the need of the modernization. So here's the agenda. We will first begin with examining the evaluation of the payment system, starting with the traditional batch processing and models, understanding why they were originally designed in that way. Next, we'll explore the drivers of the change that are pushing us for industry toward the real-time payments. Then we will focus on to the role of AI in this modern payment modernization, particularly in the fraud detection, also risk management and automated decision making. And after that, we will have a look at architecture, and then we'll finally go to the future trends, takeaways, and also the before operating the floor for the questions. So let's get started. So first is the legacy payment. What is the legacy and the batch payment? How it goes to use? So historically, batch processing made very sense because at the time the volume is not high. It was not frequent payment going to the people going and over to the bank and doing the transaction. So payment system were designed in an era when computing resources were limited, and also the transaction volume was not that high and not that under control. But now the transactions were collected over the period of time and also processed together in scheduled window, often at the end of the business day. That was how the batch processing was. And this approach optimized throughput and stability, but it came at the cost of the speed and also visibility. In today's digital economy, when payments are moved instantly, fraud, errors, and failure must also be detected instantly. Batch architecture, the old architecture cannot support this requirement, and making modernization is avoidable. Okay, so what are the drivers for the change? Okay, so there's several forces that are driving the shift away from the batch processing. Firstly, the mobile first digital economy, right? And what are the demands we have with the mobile, the instant payment experience, what every user is facing. That's the main driver. Then the global commerce require 24 by 7 availability. So gone are the days when banks are operate between 10 to 5 or 9 to 5. So those are gone days. We want Act 24 by 7 all the banking to be operated, especially online banking or money transfer scenarios. Then there are regulatory expectation, and then demand, that is where the demand of real-time monitoring and auditability. Together, this forces push payment system toward the real-time intelligent and architecture aligned with Confluence research, track on scalable and data intensity. Okay, so from batch to real time. So what batch to the real time are? So if you see previously we was using the checks, then we have the ACH clearing, then wires, cards, digital, and that's how we are in the US. We have the Fed now, the real time payment. That's the real time payment network we use here. Okay, this transition from batch to real time payments is a fundamental architecture transformation. The real-time systems operate continuously, settle transaction immediately, and rely on the event-driven processing. So in the next slide, I'll show you the architecture we are using on the cloud network, right? So this introduces challenges in the low latency, fault of the tolerance, and also distributed coordination, which are the core problems studied in advanced computing. Okay. So role of AI in the modern payments. So AI is essential in real-time payments environment. So the key to what just explaining earlier in prior session, the AI, the future trends are coming. So the most of the exception processing and others, the AI trends are going. So payments and the modern payments is no exception to that. So we do use AI in the real-time payment processing. So AI enables the detect fraud instantly, risk scoring, and automated decision making. So whenever you submit a payment, it goes through a lot of cycles, right? So all payments when you submit through mobile, it has the SLA. We have like the minimum SLA is the 15 second. So when you make a payment from your mobile, you go to any grocery shop, you do any purchase, the SLA for the banks regulatory at least has every country has SLA. In US we have 12 to 15 seconds. Transaction has to finish in 12 to 15 seconds, right, from your mobile to the account of the grocery store owner. So what happens in 12 seconds? A lot of things, and the fraud check is one of the thing. So you don't want your money to go anywhere else or stuck, right? You want money to be deducted from your account and go to the next person. So that fraud check should happen, and the fraud check is considering like let's say scanning through your all list, fraud list what they have, making sure that you are not a terrorist or anyone transferring money to another terrorist or like the actor, which is not good for the society. So that's how the fraud check happens, and this is happened real time using the AI. Then we do a risk scoring, right? What you're sending money is really is valid through or not. So also our AI and the risk scoring getting used when you open an account. Let's say you open an account with any particular bank. Previously, you used to go and submit a form, online form, go to the banks and teller, open a form. It's gonna take 3 days to open an account. Gone are those days now. You go online, you open the account, and the risk scoring, right? So when you open the account, sometimes you scan your picture also, right? You take an online picture. We call biometric to it. So all this happen online. It gets scanned through against the database of the all risk scoring items. So this is where the AI comes into picture with the automation. So it increases the official operational efficiency also as well. So these are the three areas, more or 3 or 4 areas the AI is getting used more and more in modern day payments, and is causing getting more efficiency and also the operational speed. Okay, so let's understand more about the AI in the fraud and risk assessment. So AI based fraud detection system learn continuously and behavior pattern. So any new fraud detector comes in, AI adopted it. So next time when somebody making transaction, that transaction getting scanned through that new pattern as well. So this improved detection, which causes improve the detectional and also reduce the false positive. And however, this also introduces challenges which around the governance, bias, and externality, and also the responsible AI. So I just heard, like Keith was explaining in our earlier session, responsible AI is also the new terms. So when you're using AI, you have to make sure you are using it for the valid reason and responsibly. So AI in the banks route right now, it's considering human in the loop. So whatever AI does, there is a human governance to it, right? And also the responsible AI. That is really important terms and the architecture we are using in payment modernization. So let's understand the architecture more. So if you see, this is the modernization of the AI, what we use in one of the bank modernization. So let me see whether I can zoom in. Yeah, okay. So this is the kind of architecture right now you're in college and studying in the industry, but when you go to the industry, this is where something you have to work and this is evolve eventually. So this is your the bank user, right? When you send the payment authority, it go to the request gateway and the payment for you, the payment happen, right? When you just move. But what happens underneath? The payment, right, what you made is flow through all the channels what we have here. It is go to the Amazon cloud, it's go to Amazon VPC and also the cloud network. It goes in the cache and as the payment, it check your balance and everything is fine. Just move the money to another payment, right? It also the volume component. Consider you are not the only one who are transferring money. There are billions of people at the same time for that particular bank using the money, right? Not only the online, but with your mobile, but also they have like scheduled payment, the salary payment, and also the merchant payment. This is all happens. So this is what the all happen in the background. And this is also one of the key area and also evolving right now, the modernization. So roughly like 6% bank is modernized right now. So even if you're saying, okay, I'm using my mobile, my money is getting transferred, it's very fast and easy. Why only 6% bank? But most of the bank are using their old system with your money movement, right? So with the increasing the volume and increasing the population, every bank has to do a scale up and do a modernization. So this is one of the piece of modernization what we are using, right? And scaling up from the batch processing legacy system to the real-time payments. So, okay. Yeah. So this batch processing is the event, this new payment modernization is the event-driven integration layer. So it has the AI included, AI engines, the compliance check happen, decisions happens on the runtime with the fraud database. And also when the money happens, settles at the real time, not end of the day, right? So we don't want your money to wait till end of the day to settle. So that is how this architecture is designed and getting used in the industry currently. Okay. Now the streaming and the ledger modernization. Let me see how much time I have. I hope, yeah, I have a few more minutes. Okay. So settlement and ledger modernization. So modern settlement system are real-time settlement and improve auditability. So when there is an audit happens, it's all online right now. So you don't have to wait and reconcile your balance sheet. It happens online with have the online streaming and the real-time processing. They provide resilience, transparency, and also supporting future innovation. So so data quality and governance, every bank and everything has their own governance and the regulatory compliance. So with this online streaming and real-time processing, the government data quality and governance also made easy. Also the fault tolerance and scalability. So every bank has a fault tolerance as per the government. It should not be more than 0.5% ideally. So you should not transfer a money to a bad actor in the industry or the society. So that's what we call the fault tolerance. It should not be more than 0.5%. So each country has different thing. In US we have zero point 0.3. I think in India we have 0.48%. That's how the fault tolerance set for each bank. So this is where the AI scanning and the fraud is coming to a picture. Okay. So we have the settlement and the ledger modernization. So these are the real-time settlement, right? We are not doing the batch processing, improved auditability and operation releases. And so support for the future digital assets, that's very important. So what we are supporting right now is, right now, when you use the mobile payment, you money transfer, but if you transfer the money, right, let's say from India to Canada or let's say Japan or anywhere else, it takes time. It and also the rate conversion rate what you are using is not transfer sometimes it varies, right? And also it takes a day or two sometime transfer money with some system transfer money instantly, but they charge you more, right? They have the operational fees, also the conversion rate is not less. This is where the current AI and the modernization is happening right now. We call this cross-border payment transfer. So this is where the new work going on right now. So what are the key uses for we are using for AI and the payment modernization? So real-time fraud prevention, that's what we saw earlier. Also instant payouts and the cross-border payments, proactive liquidity management, and also the intelligent payment system. These are the four major area where the currently being used, where the cross-border real-time payments is work in progress, but that is some of the bankers doing that one. So these are the key uses we are using the payment modernization and the AI on top of it. Okay. But as we go, everything has their own challenges and the risk management, right? So the challenges is that we have cybersecurity issues, we have latency issues, data privacy. You don't want your data to get exposed. You don't want your financial history to get exposed, right? And get many of the bank they use their data. You have, I don't know, in India, in US we have social security. In India we have Aadhaar card. You don't want your Aadhaar card get to leak to someone else, right? So that is what bank has to do as part of the cyber security. You don't want your personal history, your date of birth or anything get used. If that get in the bad hand, they can use it for the fraud purpose as well. So that's where the cyber security and others come into picture. Data privacy is also part of it. And also there's a model risk and governance. So any new government regulation has comes into play. Every bank has to adapt to it. That's their the policy. So this is also a challenge as we go faster route with the AI and the modernization. You have to follow the government and their the laws by laws for each country and what are the model risk are. And then the last challenge is integration with the legacy platform. So one bank has done the modernization, move to the payment modernization within AI, but another bank is still on the legacy system, which cannot cope up with the speed and the number of volume transaction going in. So that's another challenge we are facing. So if you transfer money from your bank, let's say in US, we are ICICI Bank, from ICICI Bank, you're transferring to SDFC or any XYZ bank. ICICI done the payment modernization, but not the next bank, XYZ Bank. So even ICICI is ready to send money, then the following bank is not accepting the money, right? So that's a challenge. So eventually that will settle down, but we are in that transition phase, and that is where the legacy platform with while integrating that causing the issues. Okay, those are the challenges right now what we are facing. So, okay, so we saw the challenges where they use, but what is the future of the payments, what we are doing, especially in the payments domain? So the future is the system will really leverage AI-driven autonomy, digital currencies. Many of you heard about the cryptocurrency we call as a digital stable coin. Generally is coming from the central bank digital currency we call is CBDC is the word. If you have not heard, you can Google it out. CBDCs are the currencies we are going to use. That's working progress. We call as a stable coin as well. So going forward, when you transfer a money will get moved, but when the financial systems settle the transaction, they will settle a transaction between them using the CBDCs, using we call as CBDC, a central bank digital currency, or stable coin is the term. So that is where the currently the work is going on. Also, we are the quantum safe security foundations and as a programmable smart payments. So right now we use your payments as actually the currency, right? Sending money, but you're gonna be programmed in future, right? In the next few years, you're gonna see you are doing the smart payments and programming those payment, how to send money, how to use your money, right? It's not like you have to think about. There will be a program who will you just park the money in that particular place, and those program will utilize those money, right, and sending the money to the grocery store or maybe investing into the stocks and in industry mutual funds. Those programs will take care. You don't have to have those agents in between and using those money and doing it. You will do it by yourself. That's how we call the programming in the smarts money. Okay. So what are the key takeaways? Sorry, I hope I'll take another couple of minutes. I'll wind it up. So key takeaways, right? So payments are moving faster from batch payment to real-time payments. AI enables intelligence and automation in the payment modernization journey. Modern architecture has improved trust and also speed when transferring the money. And also responsible adoption is critical to it. Like AI has its own advantages, but right, it has own challenges in terms of cybersecurity and threats. So responsible AI is really a key while we are using it in payment modernization. So I think that's it. Thank you. I'll open for any questions.
Am I audible?
Oh yeah, you are. Yes.
Sir, I have a question. What challenges do businesses face when handling payment across multiple currencies?
Yeah, so we call it a cross border. So one challenge definitely is not the consistent rate, and second is the delay. So when we are transferring the money, let's say US dollar to let's say Japanese yen, so the rate is not always constant. Today, if I'm sending, the rate could be $1 to 100 yen. It could be 105 yen. So even the rate is difference is 0.5 yen or let's say you Indian currency, right? We are transferring from $1 to 94 rupees at a time, but sometimes it's 93.5, sometimes 94.2. This changes like difference is zero point 0.5 to zero point 0.7. But considering the big industries, this Coca-Cola is companies transferring money to its vendors, employees from US to India. So zero point 0.5 rupees or zero point 0.7 rupees rate is also a huge billions of rupees at the same time. So that's one challenge. Second is the delay, because currently if they're transferring the different currency in different bank, is not instantly, it takes few hours. So few hours is okay for retail customer like you and me, but when there's a billions of dollar involved, even like few minutes is too much, because it's like interest and everything. People don't want money to be sitting idle for a couple of hours as well. So that's two challenges what we have, and those are currently being used as part of the CBDCs and the stable coins. This we call as cross-border money movement.
Yeah. Thank you so much, sir.
Sure.
Thank you, sir, for an exceptionally informative and forward-looking keynote address. With
Sure.
this, we come to the conclusion of this session. We truly hope that the discussions and the insights shared today were enriching and intellectually stimulating. On behalf of the fraternity of Amity University, Uttar Pradesh, I extend my sincere gratitude to all the distinguished keynote speakers, guests, and dignitaries for gracing this conference with their invaluable presence. We all thank all the students for their enthusiastic involvement and corporation. Thank you all.
Thank you, guys. Thank you.